Everything's all set for today's microconference?
Yep, I think
Yes,
Okay.
we're here.
Good. If there's any issue, I don't know who's going to be here from the program committee.
Ted is supposed to be here, and I believe Christian is going to join us as well.
Okay, good. I'm just bouncing around each microconference, see if everything's set. So
Say
But
hi
it goes
to
well.
everyone.
I will.
Bye. We still have 5 minutes, but we can say hello. Hi, guys.
Sorry, I'm messing with my camera.
I am there. It takes a while before you click through all the dialogues to actually enable webcam in the BBB.
Yeah, I did my experiment yesterday.
yeah, I know, but whenever when I have video disabled and I click on enable webcam, then I have to click through Firefox dialogues to enable the webcam, and to select the quality and all of that. So it's not really quick.
Hi, Ted.
Yeah, one quick hint, if folks want to use the shared notes, be aware that it's a good 6 to 10 seconds when you switch from shared notes back to chat. And so for people who want to take notes, it's not a bad idea to open up the chat room using the matrix.lpc .events web interface, so that you're not trying to switch back and forth between shared notes and chat, because the experience will be a little frustrating because of the lag time switching. So free tip.
I assume this is the right starting deck, Ted. We don't have to do the sponsors ones separately, right? This has all the information.
Yes, it's the notes on these slides.
Yeah.
then it's following a short like do's and don'ts. Oh, our first speaker has arrived. Hi,
Good morning. Can you hear me?
morning.
Lauren. Wait a couple minutes and then I'll go through the slide deck and then hand it over to you, Willie.
Sounds good. Thanks.
All right, it's 10 o'clock, so, well, 10 o'clock for me anyway. We'll get started. Welcome, everybody. It's the file system micro conference at Linux Plumbers 2021. It's good to see all of us. I'm going to do the quick little intro thing and then hand it off and we'll get started. So we're going to thank our sponsors. None of this would be possible without our sponsors, so it's a big thanks to them. And so we have the diamond sponsor is Facebook, platinum sponsor IBM, gold sponsors both ARM and Microsoft, silver sponsors Amazon, AWS, Netflix, Red Hat. The speaker gift sponsor is from Calavera. Sorry, I butchered that. It's early. T-shirt sponsor is VMware. Thanks, Steve. Conference services, of course, Linux Foundation. Linux Foundation does a ton of work for us. It's always awesome to see. Just to remind everybody, there's an anti-harassment policy. I'm not going to read through all of this, but you know, leave it up here for a second so everybody can get through it. It's you know, kind of common sense. Let's not harass anybody, please. It's good, clean fun. Please keep your microphone and camera muted when you're not actively participating. Ask questions at any time. Use the hand raise thing. We can easily kind of do that. The matrix chat is working this morning. I think it worked when I was messing with it earlier. One thing that we did yesterday, if it stops behaving, is use the shared notes to enter your questions. But you know, use the hand raising thing and chime in. This is supposed to be collaborative and you know, a working conference. So I encourage you to, participate. And try to enable your webcam first, and then unmute, and then ask the question. It makes it a lot simpler. A big, huge thanks to the planning committee. These things are not easy to do, especially with everybody being remote and trying to run a remote conference. We can see that the first day was a little rough. This is a huge amount of work. So huge thanks to Dave Woodhouse, Elena Zanani, Kate Stewart, James Bottomley, Christian Bronner, Jonathan Corbett, Guy Lunardi, Guy Lunardi, Steve. Nope, that's okay. This is other things. So my part is done. I'm going to hand it off to Willie, our first speaker, and then I'm going to get out of your way. Everybody enjoy.
Thanks, Joseph. I appreciate the introduction. Okay, so I don't have any slides because this is Plumbers, and we are here to talk about what we're going to do and how we're going to do it. So how's everybody else's month been? I've been having a great time. As you probably know, the folio patch set did not go in, and I don't have clear direction from Linus about what needs to be changed in order to make it acceptable to him. So, you know, I was hoping for a rather different outcome in the last couple of weeks, and that I would have some. This would be a great point to tell everyone, okay, here's what you need to do in order to enable your file system to go faster. I don't have that. That's not where we are. But what we can talk about, and what is useful to talk about, is what we need to do in the file systems in order to use larger pages in the page cache in order to make file system I/O more efficient. I don't think I really need. Tell me if I'm wrong, but I don't think I need to go into why we want to use larger pages. I think everyone knows that by now. The best thing you can do for your file system is to convert it to use IOMap. The IOMap, so if you're using the get block API, the bufferhead API today, convert over to using IOMap. That's for block-based file systems. If you're a network file system person, you should be talking to Dave Howells about FS cache, or the NetFS API as it now is, because that is going to have the same effect as IOMap for block devices, for block-based file systems. You will want to, it's basically a way of insulating yourself from everything that I'm working on. Both IOMap and FS cache insulate your file system from the page cache. The APIs from both those middle layers talk to file systems in terms of bytes, in terms of I've just got a correction from Dave Howells. That's netfs lib rather than FS cache. Yes. I keep meaning to say netfs lib, and I keep saying FS cache because that's what it used to be. It's kind of embarrassing because I think it was my idea to rename it. Yes. So if you're still dealing with the page cache yourself, please look at converting your file system to use one of those two layers. Obviously, there are file systems like, say, procfs, the sort of artificial file systems that don't deal with the page cache at all, and those aren't relevant right, to this discussion, because it's all about improving how the page cache works. So there are definitely features which are still missing from IOMap. I'm assuming that most of the people I'm talking to here are block file system people. There are definitely features in IOMap that the bufferheads have that IOMap is missing. And I've been talking with Derek and Jan and Ted about, what we need to do to make it possible to convert all the block-based file systems over to using IOMap. We have a little list. FSCrypt is one. Please type in the chat. Remind me of the things that I've forgotten. So yeah, FS Verity is another. There are various things which need to happen in the I/O completion path that bufferheads can do today and IOMap can't. Those aren't fundamental limitations, but there's a question, as always, of developer time. Nobody wants to be off implementing FS Verity for Okay, good. No, nobody wants to be going for implementing FS Verity and IOMAP only to have all the people who actually implement FS Verity today say, well, that doesn't work for me, and I can't use that. So as always, in Linux, it's up to the second or third person who implements something to generalize it so that everybody can use it. But since this is a second implementation of FS Verity, the one on top of Bufferheads first, and now we're going to redo it on top of IOMAP. Hopefully the people who were involved will have ideas about how to do it better. Dave Howells, Dave, do you want to just unmute and join in and say these things rather than type them into the chat and have me recite what you're saying?
So yes, I've been working on building a network file system where it started off separately from Matthew's stuff, and then I found out about Folios and I started building it on top of that. And I've been working with Jeff Layton and others to build things like FSCrypt, page cache handling, all that stuff in a separate library, which is in FSNetFS now. Currently, AFS and Ceph are using it. We're working on making it handle write stuff and cryptography. So we have AFS using it. And the main reason I want to build it in there is because if you've got content encryption, you don't want, on a file, you don't want unencrypted stuff appearing in your FS cache. So when we get content encrypted stuff from the server, we want to store it in FS cache, still encrypted. And we don't want to replicate this over the 5 network file systems, possibly 6 now that we have, or could even do this with Fuse, for example. So it seems sensible to do it in a library, try and move all the page cache related stuff out of the network file system as much as possible into the library, and let Willie loose on the library to do his foliation. I've actually been doing affiliation, and then they hit the brick wall when Linus decided he didn't like it, as is ever the way.
So I have like a slightly different question. Like I'm setting aside the process issues, like what kind of, I know you've been working on this for a long time. And so for like, my job as a file system developer is to like convert to IOMAP, which of course, we're slowly getting there, right? But like what kind of, I know these things are really thankless and hard. What kind of help do you need directly? Because sometimes it's like patch reviews or it's like design reviews, and like you send things out and nobody says anything. Like what do you wish that we would do to help you in all of this?
Okay, thank you. I appreciate the question being asked. I think from the file system point of view, I don't need very much. I have imposed on the XFS developers extensively, and they have been very, very helpful in sorting out some of my misconceptions and reviewing the patches that have gone into IOMAP, because as you know, but maybe some people don't, IOMAP came out of XFS. Like a large chunk of XFS got cut off the bottom and moved into common code. So it's been very, very helpful to me to have the XFS developers help me understand exactly what the IOMAP code is supposed to be doing. If we were going to go down the route of converting buffer heads to use, but if we're going to make buffer heads file systems support larger pages, I would need similar help from file systems that currently use buffer heads. but in talking to various people about this, that doesn't seem to be the right path to go down. It seems better to try and get rid of, minimize buffer heads rather than convert file systems using buffer heads over to using larger page sizes. So I don't think I need anything from Btrfs developers particularly in terms of doing their own, in terms of explaining what they're doing or anything like that. I think I and the XFS developers and other people who know IOMap owe Btrfs people help in doing the conversion to IOMap, and some of that's going to come in terms of code changes, and some of it's going to just be explaining what is intended at various points. But I feel like that's already going on fairly well. I mean, I've certainly seen lots of interaction over the converting Btrfs to use DirectIO, IOMap for DirectIO, and that all seemed fairly straightforward, collegial, collaborative. So I don't think anything particularly needs to change. I think we're all doing good there.
Yeah, like I said, you know, converting Btrfs to IOMap is just like a process, right? Like it's not a problem, right? I think more what I'm getting at is like this just sucks and it always falls on like one guy, right? And so the more what I like, do you need patch reviews or like, you know, just kind of like the generic, just like help that I can give you, not as a Btrfs person, but as a kernel person, right? Like as a, you know, just the mechanics and like navigating this and having somebody with you to like not bounce ideas off of, but like, you know, just somebody to like help share the load and in that sort of way to help make this be less of a like Willie gets to eat shit for a year while we all want it to happen, right?
One thing that comes to mind is, do you need help with benchmarking? Would that be helpful, or do you have that, you know, pretty much automated and under control?
I have very little in the way of benchmarking. I run XFS tests many times a day, but that doesn't produce good benchmarks. I got the Phoronix benchmarks run for me by Michael Larabelle. But yeah, I'm just not set up to do performance testing. That isn't an aspect that I'm particularly good at. So yeah,
so I also have a Phoronix test suite using GCE VM, so not real hard drives, not real SSDs, but I have something which is fairly easy to, you know, automate because I have it in a VM image. So that, you know, I'm just sort of bringing that up as maybe that those are areas where a lot of file system developers do benchmarking because we're trying to improve our file system. And so some sort of A/B testing with and without folios, if you need that, that might be one area where we might be able to lend a hand. So.
Yeah, and I've dedicated hardware for this. I have nightly XFS tests and performance tests run against our Btrfs trees, and so it's nothing for me to build folios and run my performance suites, and then you get nice, pretty graphs and shit. So like I can do that for you. It's not comprehensive or anything, but like, you know, smoke tests, right?
Yeah, if you give us a Git tree, then we can all be testing roughly the same thing. Obviously, for ext4, we'll need to, you know, we're using DirectIO for IO maps, and as we've discussed before, moving ext4 to use IOMap for buffered IO will be a process. Like, we'll probably have to do the easy stuff first and then the FSScript, FSVerity stuff later. But, you know, there's been some thinking along those lines already. So, yeah, I mean, if there are Git trees, it's relatively easy, I suspect, for a number of us to run benchmarks.
Yeah, and I'll run it against XFS. Like,
yeah.
XFS is the one that uses it, so fuck it, I'll run it against XFS. It's not going to do you any good for me to run Btrfs with folios.
Yeah. So I had another comment vis-a-vis the FSCrypt integration, and David, I didn't know you might be interested in it, so that's really, really good to hear. But as a comment, FSCrypt and FSVerity were designed to be sort of library things to make it easy to add FSCrypt to file systems. But one of the pieces that we never fully libraryized, that's not a word, but you know, is the combination of FSCrypt and FSVerity. And at one point, I had actually even thought of adding support for read-only decompression as another one of these page cache exercise things where, you know, you read data in and then you decrypt a bunch of it and then you decompress a bunch of it, or, you know, whatever order. But in theory, you might actually want to run a series of transformations on data coming in from the block device or over the network, right? So decryption, FS verification, decompression. And so one of the things that'd be great to get in a V2 version of, you know, some sort of library with these sorts of things is some sort of stacking interface, so that if a file system wants to use multiple of these modules, there's a way to do that automatically, as opposed to right now it's ad hoc done in each file system, right? Each file system says, oh, is this, you know, DM Verity? Okay, decrypt it. Okay, is this, or is this FSCrypt decrypted? If it's FSVerity, then actually check the Merkle tree. And that, if that could be uplifted, that'd be really great. So if you're going to be looking at doing work in that area, that'd be a great thing to sort of keep in mind in terms of future expansion work, even if you don't get to it right away. I don't know if any of the network file systems would find things like FSVerity to be interesting, as well as FSCrypt, but, you know, both of those are things that we need to get converted over into IOMAP, or, you know, added to IOMAP so we can take it out of EXT4 and then switch EXT4 to use IOMAP.
I haven't looked at FSVerity. With the content encryption stuff I've done, I've made it so that the network file system provides a couple of callbacks that I call, and it happens with the same signature as something that you might find in the FSCrypt library. So you can just plug the pointers directly and it will just dump straight into the FSCrypt library. However, there are two issues that that are potentially upcoming. One is that the crypto block size may be bigger than the page size, because I don't want to limit it to just 496 or whatever. And the other is, at some point, for AFS, potentially, I'm going to have to deal with pre-transport encryption, pre-transport compression. So I take, say, a 2 megabyte block, compress it down. If that's small enough, ship that over, and I may get compressed lumps back, which I then need to decompress, which brings in interesting things with the page cache. If I've got a random page in the middle of the page cache, that means I can't just splice the whole block I got back in there or something like that. Or if I want to compress or encrypt a block and one of the pages is locked, what do I do about it? I need to get the data off that page, otherwise I can't send it back. I've been looking at moving, keeping a list of regions which are dirty rather than using the dirty bits, so that I can maintain larger dirty regions than page size. Seems to be working okay. I've posted it a couple of times and I need to talk to the FSCrypt people about this.
Yeah, so I do know that FSCrypt will support, for example, 64K block sizes with a 4K crypto. That's work that Ritesh has done. It sounded like you wanted, did you want the reverse?
What I have at the moment is I create a buffer splicing the pages I have, fill in the extra pages I don't, and then if I'm reading, download a larger block.
Yeah.
Then call the crypto on the sub crypto blocks of that, because I've got the IO, the server's IO size to deal with as well. So if it's something like Ceph, I may want to download a 2 megabyte chunk from that particular server, then decrypt the small bits of it, and then do something with the pages.
Yeah, so
have that working, but
yeah, I mean, obviously, especially with FSCrypt and the goal of supporting huge compound pages, I think there's opportunity to make FSCrypt be able to handle that situation much more efficiently, because that's going to be a lot of the value of folios. And if we're using FSCrypt, and the first thing we do after we get a huge folio is to break it up into individual 4K blocks, that's not ideal. I suspect I don't want to be taking over the this section talking about FSCrypt plugins, and some of the FSCrypt folks, such as Eric Biggers, almost certainly aren't here. But that might be one of the things that we could set aside time, either at one of the EXT4 weekly conferences, or we can set up an ad hoc meeting to sort of get all the interested parties in one place.
yeah, that'd be good.
Yeah. So why don't we do that? And I don't want to like turn this into an FSCrypt session. So
Thank you. I was about to say, Kent's been waiting for a few minutes to talk, and I think we should probably let him say something.
Sorry, did you say my name?
Yeah, you put your video on, which is usually a hands up, I'd like to talk indicator.
Oh, I expected I might be jumping in, but I didn't have anything right at the tip of my tongue.
Okay, sorry to put you on the spot. So Kent and I have been talking for a couple of days now about the getting deeper into getting folios merged.
I did actually just comment in IRC, and it might be pertinent here, that I think the discussion on the list did go in a more productive discussion. Andrew made a comment that he was still waiting for the process to play out on the list, and I think we did make some progress in actually figuring out what people's real objections were, and that they didn't even necessarily apply for the stuff that's queued up for 5.15. I think none of us had fully delved into the patch series, and also with you gone on vacation, we just didn't realize that none of those patches were actually touching anonymous pages. And since they're not, I don't see any real holdup to what you've got queued up for 5.15 going in now. So it might be good to ping Andrew and see what he thinks.
Okay. Thanks. I'll have a go at that. So anything else?
Matthew, I just want to say the 3 minutes queue, and maybe for fun, shall we have a poll about the name?
I really like
It's gonna.
I mean, we'll get used to any name, whatever
Just
name
for
it has.
fun. Just for fun.
No, it's not
No?
fun for me. Not fun for me.
Okay.
All right. So, anything in the last 3 minutes? Is there anything anyone else wants to talk about the page cache and file system interaction, regardless of the name? If not, then I think we can hand over to Christian.
Yeah, so I had one quick comment, which I don't know that we can resolve here, but I want to at least identify it. Someone observed to me offline that he was under the impression that a lot of the MM folks didn't really seriously take a look at folios until the request to merge it came in, because they had some sort of cultural expectations that stuff in MM takes forever and a day, and until there's a request to add it to Andrew's tree, no one was going to take it seriously and take time to look at it. And so I think one of the things that is probably worth thinking about is, I know you've been talking to a set of developers, but we maybe want to try to probe how do we make very, very clear and explicit what the review procedure inside all of is, because it was pretty clear when I was looking at the email thread, there's disagreement inside the community over, whether or not we need to handle the anon bits first, the anonymous map first. And so I have a feeling it's not just you, and it's not just Andrew, and it's not just Johannes. There may be an overall process question of how the subsystem as a whole makes decisions. Because Andrew made it very clear that he thought things hadn't been fully explored yet. And I think that's sort of symptoms of an underlying issue that probably requires some additional, discussion so that we all understand what the ground rules are in terms of review and getting consensus. Because I don't think there's consensus inside the community. So just to put it out there.
The only person who's actually expressed that they don't want this is Johannes. And I think that's based on his not really understanding what folios are about. Hugh is not particularly enthusiastic about it because he sees how much churn it is and he thinks it's more churn than it's worth. Everyone else is either silent or is in favor. As far as I may have missed somebody, but I've got a lot of people who've act individual patches, and
I think Johannes is honestly trying to relay the concerns of some other developers as he sees it, and also I think he did bring up some pertinent concerns that are more of a future roadmap thing than things that should be holding up the patch set for 5.15. And I think something that's come up in a number of discussions is that we don't have anyone doing real design work in land to get people on the same page and working in a common direction. That came up with Dave, with Johannes, and I think it would be really helpful if, and I think your work is the closest that we've had to this, if we had someone coming up with an actual plan for how do we deal with the struct page mess. I think a lot of the why this has become so contentious is because we have state from different subsystems all mixed together, and that's made it I think a lot of this, what the contention has come down to is everyone sees that this is a mess, and everyone sees different aspects of the mess. And your work is cleaning up one part of that mess, and people are a little bit upset that their parts of the mess aren't being cleaned up right away, when really, if we had an explanation of the end goal that we're working towards, everyone would see that, oh, this is where my concerns are addressed.
Guys,
we're
let's
gonna
go for our next talk.
Yeah, thanks everyone.
Thank you, Matthew,
Thanks, everybody.
everyone.
Hello, I think you need to make me presenter, Amir.
All right. You do have this power, don't you? You do. It's not.
Oh, now I do. Now I do. Okay, hopefully you can all see this. Really lacks in slides. I'll probably make up for in slides.
So, Christian, do you plan to speak for like about 30 minutes and leave some time for the project ID issue?
Yes.
All right.
That's the goal. Welcome everyone. Very happy to see you all here, even though it's just virtual. But hopefully we'll be back to an in-person event next year. big thanks to Amir, Josef, Jan, and Derek for organizing the micro conference. It's very much appreciated, and very happy that we have a file system micro conference at Plumbers this year. And for those who don't know me, I'm Christian. I'm one of the organizers of Plumbers. I'm also quite happy today to be talking about ID map mounts work we did over the last years, which is ultimately, though, a patch set that is very, very old. So I'll be covering various things, and hopefully it's not too boring for all of you, but I think it helps to understand the motivation and implementation later on. So we express ownership information in the form of UIDs and GIDs. I mean, that should hopefully be not very controversial. And the kernel, and here specifically the VFS, uses this information to check permissions or to determine whether a caller is allowed to interact with an inode or not. Okay, so most block device-backed file systems, so file systems that have FS requires def set, will persist such ownership information in some way or another. So such file systems will store ownership information on disk. And there are exceptions, of course, as always, like file systems that do not implement a proper form of DAG. VHFAT, for example, don't store information on disk. And for such file systems, there's often a way to determine ownership at mount time through UID and GID mount options, for example. So obviously the VFS needs to learn what ownership information to use for a given file. And so when a lookup operation, for example, is initiated, a new struct inode will at some point be allocated, and the file system will read the ownership information from disk and then store it in struct inode in the IUID and IGID members. And the ownership information is filled in by calling two well-known functions, I hope, IUID read and IUID write. The IUID read function is used when reading ownership information from struct inode and writing it to disk. And the IUID write function is used when reading ownership information from disk and storing it in a struct inode. And so the naming sometimes can be a bit confusing here. The read and write are taken relative to struct inode. So either struct inode is read from or written to, and when viewed this way, the naming actually makes more sense. And so the interesting bit here is that under the hood, IUID read and IUID write functions don't just transfer ownership information from or to struct inode to disk, they also perform a translation in two ways. So the VFS itself doesn't deal with raw UIDs and GIDs as stored on disk, but for a long time with KUIDs and KGIDs. And the IUID read and IUID write function internally call two functions under the hood, so make KUID and from KUID to translate raw UID and GID values as stored on disk into and from KUIDs and KGIDs. And so the IUID read function calls from KUID, which translates KUIDs to raw UIDs, and the IUID write function calls make KUID, which translates raw UIDs into KUIDs. And for all interesting file systems, most block backed file systems, this translation between those two types is an identity translation with respect to the actual value. So meaning that the value that is stored on disk is usually the same as the value that is stored in struct inode. So for the common case, IUID read and IUID write will yield different types, but with the same value. And there are obviously circumstances where the actual values can differ, and this is where we sort of need to be looking at ID mappings for a bit. So ID mappings during this talk, at least, are essentially a translation of a range of IDs into another one or the same range of IDs. And the notational convention that I'm going to be using during this talk is UKR. And in the context of the kernel, we can interpret the ID mapping as a mapping a range of user space IDs into a range of kernel IDs. And so note that we are only concerned with ID mappings as the kernel stores them, not how user space would specify them or set them up. So for the rest of this document, we prefix all user space IDs with U and all kernel IDs with K, and ranges of ID mappings will be prefixed with R, and we will use user space ID map set or kernel ID map set to talk about the sum of IDs that are contained within a mapping. And so a kernel ID is always created by an ID mapping, and such ID mappings are associated with struct user namespace. Since we mainly care about how ID mappings work, we're not going to be concerned with how ID mappings are created or how they are used outside of the file system context. And so the initial struct user namespace is similar to the initial struct mount, where every user lives when they log into the system. without doing anything, always has an identity ID mapping. So an ID mapping where 0 maps to 0, and then the whole range of IDs. So it's an identity ID mapping over the full range of IDs available on a given system. And there are other struct user namespaces or other contexts that have non-identity ID mapping. So for example, see here where you map 0 to 10,000 for 10,000 UIDs and GIDs. And there's an algorithm, a simple one, where you can calculate what a given ID maps to. It's fairly straightforward, but is there a typo? No, there isn't. First, we need to verify that the range can contain our target ID, and we will skip this step for simplicity, otherwise the slides will get too full. And after that, if we want to know what ID maps to, we can do very simple calculations. So for example, if we want to know what 1000 maps down to according to the ID mapping, so what kernel ID it corresponds to, we subtract, we take that ID, we subtract the first user space ID and add the first kernel ID, and then we get 11,000. And if we invert this mapping, so we go back to the question, what raw value corresponds 11,000 to, we take this kernel ID, we subtract the first kernel ID, and we add the first user space ID, and then we end up with the same ID that we started it when we fed it into make KUID. So these algorithms essentially invert each other. So back to IUID read and IUID write, which is why I've been talking about this in the first place. So we saw that they translate between raw UIDs and GIDs and KUIDs and KGIDs. So let's say the VFS has initiated a lookup operation and struct inode wasn't present in the iCache. So we end up calling into the file system to fill in struct inode with relevant ownership information from disk. So consider a file that is stored on disk by a file system as being owned by the raw number 1000. And as we saw for most interesting file systems, X4, XFS, Btrfs, they are mounted with the initial ID mapping. So we see that this is simply the identity mapping, right? So this would mean IUID write would read 1000 from disk and return KUID 1000, and struct inode would therefore contain IUID and IGID 1000. But if you are dealing with a file system which is mountable with a non-identity mapping, such as 0 to 10,000 for 10,000 UIDs and GIDs, then IUID write would read 1000 from disk and return KUID 11,000. So struct inode IUID and IGID fields would contain 11,000. And you see some of the functions that the file systems use here. So the other way around, the IUID helper comes into play. So when we go in the other direction. And the VFS calls into the file system, for example, because it has created a new file or because the ownership of a file has changed. And in either case, at some point, we need to transfer the ownership information stored in struct inode to reflect the correct ownership on disk. And sticking with our earlier example, where we had a file that was stored on disk as being owned by UID and GID 1000, if we are talking about the initial mount and user namespace, then the IUID write helper will have written 1000 to struct inode, and consequently IUID write will do nothing because the identity mapping, we get 1000 back. And but look at the case where we are dealing with a file system that is mounted with an ID mapping where you map 0 to 10,000 for 10,000 UIDs and GIDs. We saw that if we feed 1000 into IUID write, we get kernel ID 11,000. Sorry, there's a typo in here. So when we want to write ownership to disk, we need to reverse this ID mapping. And IUID read will consequently translate 11,000 back to 1,000, which is what will be written to disk ultimately. So this translation into both directions guarantees, essentially, if you look at this from a mathematical perspective, that it is an order isomorphism. I see Ted is asking questions. Then you just get the overflow and overflow UID and GID. So any ID that isn't mapped will be represented by the overflow UID and GID. But I can answer those questions after the talk. So the other thing that we need to know about is creating new files. So the ID mappings don't just figure into the VFS disk boundary, they are also important when we cross the user space VFS boundary. So to illustrate this, we can look at what happens when we create a new directory. It could be anything, file, whatever. When creating a file system object, the VFS will look at the caller's file system IDs, which are just regular UIDs and GIDs but they are exclusively used when we determine file ownership, which is why they are called file system IDs, which most of you should know. So when the caller enters the kernel, two things happen. So first of all, the kernel will map the caller's user space IDs into kernel IDs according to the relevant ID mapping of the caller, which is essentially just stashed in current FSU ID as part of the caller's credentials. So this translation doesn't happen every time you enter the kernel, obviously. And second, it will verify that the caller's kernel IDs can be mapped up to user space IDs in the file systems ID mapping, which is what FSU ID and GID has mapping is doing. And this second step is important because, as we have seen, regular file system will ultimately need to map the kernel ID back up into a user space ID when writing to disk via IUID read. So with the second step, the kernel guarantees that a valid user space ID can be written to disk. So if it can't, then the kernel will refuse the creation request. So ideally nothing ends up in the file system that you can't write to disk. So you don't write -1 to disk, for example. So what the VFS does is to translate between two different ID mappings, technically using the kernel ID map set of the two ID mappings. And the relevant ID mappings are the caller's ID mapping and the file system's ID mapping. We will see this now, what I mean by this. So take the VFS make dir example. And so I listed the relevant mappings in the caller's user space ID. I like to call this algorithm cross mapping because you're essentially connecting two ID mappings. So a caller with UID 1000 enters the kernel, and the caller is located in an unprivileged container where they are subject to an ID mapping where 0 maps to 10,000 for a range of 10,000 UIDs and GIDs. And let's say they're interacting with a file system that is mounted with an ID mapping of 20,000, which maps 20,000 to 10,000 for 10,000 UIDs and GIDs. And this is really weird, but we have seen stranger things happening. It's a difficult scenario to get into, but you can make it happen with mount propagation and so on. So first, the kernel will map the caller's UID 1000 down into kernel ID 11,000. This is what we have seen before. This is what current FSU ID will have stashed in the caller's credentials. And then it will perform the second step, which is, can I represent this value when I need to write it to disk, which the VFS is verifying. So I do from KUID, I'm mapping it up into file systems ID mapping, and see if 11,000 resolves to something meaningful. And if it does, if I get a valid value and not an invalid UID or GID, I know the file systems ID mapping can represent that value, and then I can go on writing it to disk. So this is the cross mapping I mentioned. So to note here is that we have all the pieces to understand how the VFS disk boundary works, and the user space VFS boundary works is handled with respect to ID mapping. So the IUID read and IUID write functions will always be looking at the ID mapping of the file system itself. So the point that I want to drive home here is that at this point is that the world prior to ID map mounts, file ownership could only be changed either via chown or by making the file system mountable by unprivileged users. So allowing a file system to be mountable by unprivileged users has consequences. Yes, you get file system ownership changes on a file system-wide basis according to the associated ID mapping. And this information is represented in the file system superblock, and it's usually determined at mount time. But it's important to note, first of all, that most file systems don't allow this to protect themselves against malicious file system images. And because creating a superblock is arguably a privileged operation that should be under control of the administrator, at least for some types of file systems. And all file systems mountable with ID mappings currently are non-FS require Steph file systems. So stuff like tempfs, sysfs, procfs, devpts, binderfs, and recently overlayfs. So before we look at ID map mounts a bit deeper, I want to talk about a few select modern file system use cases. Like there are obviously a lot of them, and these are the ones that I find very interesting and that are currently very pressing, and that provided some of the justification for ID map mounts. So new systemd versions implement a concept called portable home directories. I don't want to know how many eyes just rolled when I said systemd. I hope not too many. But the idea is to provide a way to make to take your home directories from one computer to another, independent of the login UID and GID assigned to you on that system. So essentially having a random login UID and GID. Yeah, Joseph, great. The idea being that the assigned login UID and GID can be essentially random. And most users will have user ID 1000 as the login ID on their machine at home. And all files in the home directory will usually be owned by on disk by UID 1000. And so at uni or work, for example, they might have another login ID such as 1125 or 1001. This makes it rather difficult to interact with their home directory on their work machine if they have it on an external drive or a stick. So in both cases, changing ownership recursively via chown, for example, has grave implications. The most obvious one is that ownership is changed globally and permanently. And in the home directory case, this change in ownership would even need to happen every time the user switches from one computer to another. And for really large sets of files, this becomes prohibitively costly. It's also, we have seen cases where recursive chown for whatever reason fails, then you're left in a state where you have some files with changed ownership and some files with not changed ownership. So it's really not a workable solution. And if the user is lucky, they are dealing with a file system that is mountable unprivileged, but then this would also change ownership globally. The change in ownership is then tied to the lifetime of the file system mount to the superblock. This could work, but we've seen it's unlikely that the file system you're using on your home directory will support it. And it also means that you will lose a lot of privileges, as you will also need in your mount namespace most likely, and your user will likely need to be located inside the user namespace the file system is mounted in. I hope you can still hear me. Sorry,
Yes.
Bluetooth is not working very nicely on Linux yet, at least for me. So if the user is lucky, as I said, they can mount it, but unprivileged, but usually not something that works. And you're limited insofar as you might be you need to be located inside of user namespace yourself, which is not what you want if you're a regular user that just wants to log in on their work machine. And so love them or hate them, they are everywhere. Containers, obviously, this was supposed to come up, I guess. And more and more runtimes try to make use of unprivileged containers. So containers that deal with ID mappings. But mind you, we introduced them around 2013, and they still aren't widely adopted. So not a lot of, if you run Kubernetes, you're not seeing unprivileged containers, you're seeing privileged containers. And one of the main reasons is that the file system question wasn't solved. So, but runtimes such as, for example, LXD, systemd, nspawn, and so on, run unprivileged containers by default everywhere. And more runtimes are trying to do the same. So the problem obviously is that unprivileged containers affect file ownership, so containers run into various problems rather quickly. The first and most obvious one is that the file ownership of the root file system of a container needs to correspond to the ID mapping the container uses in order to interact with the file system. And this usually nowadays is achieved by recursively chowning the root file system if you're using unprivileged containers, or by mounting it unprivileged in the container. But as we've seen, both solutions have drawbacks and they might not even be available. Like, for example, the Chrome OS guys, which are using LXD to run unprivileged containers, they try everything to prevent a recursive chown. First of all, to not stall users using their machine. And also because what if the chown fails? What if the like X adders are not translated correctly or preserved, and so on? So you see that often this is a no-go even in the container world. So another problem is sharing data from the host with an unprivileged container. Host doesn't have an ID mapping, container has an ID mapping. The only solution in this case is to recursively chown. We can't mount the file system inside of the container because it is already mounted on the host. And also because we wouldn't be able to share it with the host if we did mount it in the container, not easily at least. You need to mess around with mount propagation and so on. And similar problems apply when trying to share data between unprivileged containers with different ID mappings, which also some users do to harden their workloads essentially. And in this case, one container will likely always end up with files it can't interact with, because chowning to the ID mapping of one container will necessarily render the file system inaccessible to the other container. And so all of those cases and more want a way to temporarily and locally restrict change the ownership of a set of files with read-write access. And so this is where ID map mounts come into play. This is not like a brainchild that came out of thin air. Like there were a lot of people that that we have discussed and discussed this with, and who have provided either input on the API or on the initial implementation. So ID map mounts start with the idea essentially that file ownership really should be expressible on a per mount basis instead of a file system-wide basis, similar to how you can have read-only mounts and not only read-only file systems. So they allowed to expose the same set of files with different ownership at different mounts. That's the goal at different mounts. That's at least the goal. And the ID mapping associated with it is then used to translate from the caller's ID mapping to the file system's ID mapping and vice versa, using simple remapping algorithms. And ID map mounts make it possible to change ownership in a temporary and localized way, as I said. That's at least the goal. Localized because the ownership changes are restricted to a specific mount, and temporary because the ownership changes are tied to the lifetime of a mount, and all other users and locations where the file system is exposed are supposed to be unaffected. And file systems, you could make an argument that file systems that support ID map mounts don't have any real reason to support being mountable unprivileged, because a file system could be exposed completely under an ID map mount to get essentially the same effect. But there are some reasons exist. For example, if you say that making a file system mountable unprivileged gives you full rights over the IOCTLs associated file system wide with the file system type, then that's an argument that you could make. So this is the advantage. File systems can leave the creation of the superblock to privileged users if they want to. So, however, it's of course perfectly possible to combine ID map mounts with file systems mountable by unprivileged users. This isn't possible right now, but the algorithms we'll see in a bit allow for it without a problem. We just didn't have the need to do it right away. And the use cases above and more are handled by ID map mounts, and they already are handled by ID map mounts in various applications. And I also, if we have the time, I can show a quick demo. And so ID map mounts work by employing rather what I call simple remapping algorithms. I have written long documentation about this that's in the kernel. And this happens in 2 locations, roughly. It's obviously shortened. A file system ID map, wide ID mapping, as we saw, is nothing but an ID mapping that is applied at superblock creation time, which maps a given raw UID and GID as stored on disk to some other value. And the mapping is then reverted when actually placing those values to disk. And ID map mounts work similar. So they translate the kernel ID from the file system-wide ID mapping to the mounts ID mapping via the user space ID map set of the 2 mappings. And this is equivalent essentially to remapping the raw UID and GID values. So essentially it's what IUID write does. It's just on a per mount basis. And this is what IUID into mount is doing. So it maps the file systems ID up into a user space ID in the file systems ID mapping, undoing the file systems ID mapping, and then applying the mounts ID mapping. That's why I call it remapping. And the mapped FSUID helper is the other side of the equation. So the user space VFS boundary, which takes care to translate the caller's kernel FSIDs into kernel IDs in the file systems ID mapping, again by remapping the caller's kernel IDs using the mounts ID mapping. And together, this ensures that similar to IUID read and IUID write, that you have an information preserving order isomorphic translation algorithm. That's how you can put it mathematically. You can actually prove that they are order isomorphic and information preserving. So this ensures that when a file is created, the correct ownership is put to disk. And usually this is done via the cross-mapping algorithm that we've seen above. So where you translate between the caller's kernel IDs and the file systems ID mapping. This is mapped FSUID is essentially just doing this, but for ID map mounts. So let's look at an example again. I took the VFS makedir example and back to the portable home directories case, so to speak. So assume you have a user that has UID 1000 on their home computer, right? So, and they now move to what you see on the slide, to a work computer where they are assigned login UID and GID 1001. So all files in their home directory belong to UID and GID 1000, and they like to keep it this way. So they don't want to go to their workstation, then create a bunch of files, and then go back home and suddenly end up with a mixture of 1000 and 1001 files. Half of which they can interact with and half of which they can't interact with. So when the user plugs in their portable storage at their workstation, they can set up a job. Systemd is doing this. That creates an ID map mount with the minimal ID mapping, in this case, that just maps UID 1000 to UID 1001. And so now when they create a file, the kernel performs the following steps, the ones we already know from above. So the current FSUID steps. So map the caller's user space IDs into kernel IDs in the caller's ID mapping. And then the second step is translate the caller's kernel's IDs into a kernel ID in the file system's ID mapping, in the mount's ID mapping, sorry, with mapped FSUID. And then last but not least, it's when we place the actual value to disk. So verify that the caller's kernel IDs can be mapped to user space IDs in the file system's IDs mapping. So 2 and 3 together, with the mapped with the mount's ID mapping applied, form FSUID GID has mapping, just here split apart and split into separate steps to sort of get a look at the bowels of this function. And so ultimately the file will be created with the raw UID on disk, UID 1000 on disk. So let's look at, if we want to know whether this algorithm really works, we need to look at the other direction as well. So now we created a file. Now we want to know if I request who is this file owned by, then I should hopefully see the correct information. And so this is essentially what VFS getAttr together with copy statx would be doing. So again, we are at our workstation. We have call ID 1001 and the caller's ID mapping and file systems ID mapping are the identity mapping. And we have set up this job whereby 1000 is mapped to 1001. And so now the file system reads the actual ownership from disk. So it calls IUID write. And because it's an identity mapping, you will see 1000 is put into struct inode. And then we call translate the kernel ID into a kernel ID in the mount's ID mapping using this IUID mount into mount algorithm that I mentioned above. So we undo the file systems mapping, apply the mount's ID mapping, and then we see that it's kernel ID 1001. And because the caller is located in the initial user namespace, and when we finally report back to the user what UID this is actually owned by, so when we finally do copy statx, which is the last step in the equation, we report back 1001 to the user. So ultimately, the caller will be reported that the file belongs to 1001, which is the caller's user space ID in this example. And so if the user goes, this is really important to notice, if the user goes back home in their home station and plugs into a USB stick and there isn't any of this ID mapping stuff applied, they will see 1000 all the way. So the API to create ID map mounts requires the new mount API, which is great that we have that. I'm a big fan of that. And requires the mount setAttr system call. This is independent of useful of ID map mounts. It allows to change the properties of a single mount or entire mount tree, and something that wasn't possible with the legacy mount system call before. So users can specify the mount attr ID map flag together with a file descriptor referring to user namespace. And whenever callers interact with the file system through an ID map mount, the ID mapping of the mount will be applied. And in order to create an ID map mount, we have a few restrictions in place. The first two are the caller must have the capsys admin capability in the initial user namespace currently, and the file system must not be mountable in a non-initial user namespace. These restrictions can be reasonably relaxed if it proves to be necessary in order to support further and more complex use cases. So not to worry. It's not that this is dead set and we can't do anything. We thought about these cases before, and we thought about the need, for example, to also maybe support file systems that are already mountable by unprivileged users. And they just weren't necessary right away. And I didn't want to rush it. So then the underlying file system must support ID map mounts. So it's not that now suddenly all file systems support ID map mounts. No, you need to set a flag similar to FS require Steph, although that's not really up to you. FS allow ID map needs to be raised in the file system's flags. And the mount must not already be ID mapped. So this also implies that the ID mapping of a mount cannot be altered. We don't want to suddenly all of life cycle becomes messy, and it's messy for user space if you have an attached mount that suddenly changes ownership. It's something that I think we shouldn't support. And the mount must be a detached mount. That is, it must have been created by calling OpenTree with the OpenTree clone flag, and it must not already have been visible in the mount namespace. So to put things another way, the mount must not have been attached to the file system hierarchy with a system call such as move mount. OpenTree is part of the new mount API in case you're not, I don't know how many people actually need to program with this in user space as well as in kernel land. So before we take a few minutes to look at a demo, I think we can still make this. ID map mounts are obviously a VFS feature, but need some support from individual file systems. So as I said, file systems need to mark themselves with the FSLR ID map flag, and they need to be ported to the new ID mapping helpers. Currently, this includes X4, XFS, ButterFS, and KSMBD, I think now. And there is already a support for NTFS3. I don't know what the status of this is, probably merged upstream, NTFS3 now. And there are more file systems to come, OverlayFS being one of the ones that people keep requesting right after ButterFS. And especially for core file systems such as X4, XFS, and ButterFS, the patches have been rather straightforward and small, I hope. So file systems are also not really ever exposed to any of the low-level helpers, unless they do really custom UID and GID stuff already. There are higher level abstractions in place that operate directly on struct inode and don't require the file systems to touch UIDs and GIDs directly, whenever this can be reasonably avoided. And we do have extensive FS tests for this, and also for file system specific features such as for ButterFS. User space has jumped on this fairly quickly, for better or for worse. And we have working implementations for Lexi, systemd, there are containerd patches out. There's more discussion and patches for various other projects. Try to keep in contact with the people that have a stake in this and are interested in seeing this work evolve. It's also important to note that this is not a container feature. I think this is important to notice. It's really about making file ownership expressible on a per mount basis at its core. And yeah, last but not least, I think I need to thank Christoph for having a bunch of good ideas around this years ago. Seth and others that have helped with this. Thank you to the file system maintainers that have helped with this and were very responsive. Derek, Joseph, David, Ami, and Ted. We might have a few seconds to look at a demo. I try to.
Christian, I just want to say, I look at the chat and I think people are
go ahead.
a bit confused, have a hard time to understand. It's a lot to grasp. I know it took me a while to get my head around this. So just take a short peek maybe at the stream of comments. I think Ted has a question.
Sorry.
And generally, I wanted to raise one thing.
Mm-hmm.
I don't know if this all started with the ShiftFS or it started before that. Mm-hmm. But I know that the use case, the very simple use case that James brought up was just mounting an image, like an image that was owned exclusively by a container. Like you had an image, an ext4 image with UIDs 0 to 1000, and you have a user namespace where you do not own those basic UIDs, you own the shifted UIDs, and you just wanted to shift back to those native UIDs.
Yes.
So maybe it's a simple example that people can.
Yeah.
It's easier to wrap your head around this.
It's essentially the same idea, though. James's idea has always been kind of similar in the sense that we fairly early on realized having this a feature that is done on a file system basis will not allow you to solve a wide variety of use cases that exist.
I'm not talking about the implementation. I'm just talking about the use case. The use case that James presented was very simple to understand.
Yes.
Now, maybe some people understand home home directories, or but it's a
Yes.
simple use case.
Yes, I hope this helps. So let me go to the chat real quick. Morning.
And also, we do want to leave some time for the project
Yeah.
ID notes.
No, that is memory discussion.
Oh, yeah.
Okay, so if a file system in a non-init FS has UIDs which are out of range of the mapped user IDs, yes, all of these files, as I said, Ted, will be represented by the overflow UID and GID. Yeah, the inode will be initialized with overflow UID and GID essentially. So all those files will appear to be owned by nobody, no group in user space.
There's a question further down about bind mounts. That Ted
Yes,
asked.
so Carlos asked, yes, currently they require super user privileges, but I have thoughts on relaxing this restrictions. Not thoughts, I have thought about this various ways how we can do this. I just didn't want to do it right away. We jumped with various features we jumped on the make it available to unprivileged user bandwagon way too early.
Yeah, and I think you answered my bind mount question, which is currently it doesn't work on bind mounts because if the file system is already mounted on with an ID mapped, you don't allow another ID
Yes.
map. So I assume that means we don't support bind mounts today.
The ID map is on the mount point, not the super block. So I think it should work with bind mounts.
So if people remember the use case that I referred to that James brought up, it was just an image, an ext4 image, loop mounted inside a user NS, and he wanted to be able to use the native IDs. So he wanted to shift the IDs back for this specific file system from the shifted up UIDs down back to the native UIDs. And if my understanding is correct, so this is done today using ID map mounts by creating yet another user namespace. There was another question about that. Another user namespace with the exact reverse mapping, right, of the initial user namespace, and use that reverse mapping to map the high UIDs back to the native UIDs. Is that how it works?
No, look at the,
No.
it's essentially just attaching it's really just about if you have a file system that is mounted in the initial user namespace, everything is owned as you would expect it, and then you start a container and give the container any kind of ID mapping. You just need to attach the same ID mapping to the relevant directory that you want to delegate to the container. That's it.
Right.
Ah, yes. So
Christian, how long is your demo? Because maybe we want to give John some time to present his few slides.
we can. I see we have a very helpful comment from Eric as usual. Say download an image and an ID map mount to the container's namespace. Yeah, I mean, that's a possible use case. I mean, what a possible use case, like for example, systemd nspawn. This is what they want, the systemd nspawn, and for example, so you can't really drop a setuid binaries in there, no. So the case, for example, that systemd nspawn has and that we would see in the demo is, which probably I can show real quick, is that the directory where the container is located, so for example, here for systemd nspawn, that's the case. Here you see that they just create a directory that is only accessible by root, so var lib machines in this example, for example, and systemd nspawn and lexi are cases where the on-disk ownership of the files isn't changed at all. So they just want to download an image, unpack it, and then they say, give me an ID map mount. They start it.
Can you make your font bigger, please?
Oh, I don't know if that's possible. Is it really that hard to see? You can see it has an ID mapping, and then yes, they just attach the same ID mapping as the container, and then they want all of the ownership to match one-on-one with what they had as they unpack the image. However, it's perfectly possible if you wanted to do this, if you wanted to be on the secure side of things, so to speak, you could no worries change the ownership on this to something, to whatever you want essentially, and then create a dedicated ID mapping or a dedicated user namespace that attach to that mount that gives you exactly the ownership that you want and takes care that you, for example, write to disk with totally unprivileged UIDs and GIDs. That's totally possible. You could also not set up an ID mapping for UID and GID 0, for example, as we do in the home directory or systemd homd case. And Case, what did you say?
Yeah, so the demo is harder to see.
I was just saying that the screen is half the height of what you're sending.
But Christian, let's give the presentation to Jan because the time is up, and we're entering the break, but we're still going to go with another discussion that we wanted to follow ID map mounts. I'm sure we can keep discussing on the chat and afterwards. So, Jan, do you want to take presenter? And thank you, Christian.
Sure. Thank you, Ami, for having me.
Oh, John, I've already uploaded the slides. You can press the plus button and the slides should be already be there. At the bottom left.
I see. Okay. Hi, everybody. Thank you. So I have just 2 quick slides about project IDs, which we wanted to discuss. So this is kind of a common topic we talked about with Derek and Ted, and basically project IDs and also Amir. So project IDs, maybe not everybody knows, but this is another 32-bit identifier that's stored in an inode in addition to UID and GID. It's persisted on disk for ext4 and XFS at least. Not sure if any other file system currently stores this. And originally it was used, it comes from IRIX, and it was used to implement kind of cooperative space control. So basically the idea was that each project got assigned some ID, all files of this project were belonging to this ID, and there was quota so some space limitation for all the files of this ID. Now, because this was cooperative measures, and basically you could change the project, you can change the project ID to any number you wish. It's not enforced in any way. With the advance of user namespaces, like this has changed. So like currently this cooperative control is not very useful, or at least, well, not many people use it like this. And on the other hand, container people like expressed interest in controlling space usage, for example, of containers or some other stuff using something like project IDs and then project quotas. So current behavior is that in initial user namespace, inode owner can set project ID to any value he wishes. In a non-initial user namespace, you are not allowed to change project IDs unless you have like capsys admin or so. You are not allowed to change the project ID at all if you are not in init user namespace. And project IDs are, and then there is also a question like how project IDs should behave in terms of mappings. So like as Christian has shown in his talk, like UIDs and GIDs are getting mapped on various occasions as passing through the stack. Now, there is also project ID mapping that's attached to user namespace, but it's not applied consistently. So there are places like mostly inside file systems like XFS ext4 when getting the IDs from user space or when storing project ID to disk, then the IDs are not mapped at all. But for example, when VFS quota code gets the ID or actually operates with the IDs, then the IDs actually do get mapped through user namespace. So there is this inconsistency, and that basically makes any non-trivial project ID mappings effectively useless and unusable. So to this, there is also like related project inherit flag. So you can set that flag on a directory called project inherit. And if it is set on a directory, then all files or directories newly created inside this directory will inherit the project ID of the directory. And the directories will also inherit the flag. So basically this results in a recursive like ownership of the directory tree by a single project ID. Obviously, still you can change the project ID afterwards to anything, so it is not a hard guarantee, but it's kind of like helper for default behavior, let's say. And the rules for modifying this flag are the same as for modifying project ID. So this is the current behavior of project ID. Now, we were discussing how we could possibly change this to be more useful for containers. So one big question is whether we should just not bother mapping project IDs at all, or whether we should consistently apply project ID mappings based on the mapping specified in user namespace. So that's one big question. And the other question is like the semantics of currently allowing inode owner to change project ID only inside init user namespace is kind of confusing. Some people expect the project ID to not be changeable unless you have like sysadmin privileges. These were some users coming with like surprise. So basically, so that even in init user namespace, you can somehow use it to enforce some kind of additional limitation on the particular directories or stuff like that. And on the other hand, there are also some wishes to like make project IDs changeable to some extent inside non-initial user namespace. So basically, when you are in a user namespace, like inside a container, you should still be able to get some control over the project IDs of the file and be able to change them, at least in some, let's say, limited range or whatever. Yeah. So basically, based on the use case, we would have to define the semantics. So here I have like open up for discussion if people have like suggestions how or know how if they use project IDs or would like to use project IDs for something, or if Amer has anything to add.
Yeah. Well, first of all, I just want to say that the project IDs are used at least by Docker as a way to manage usage of files in a container. And we also have a proposal on the list for how to make that a little bit more robust, the behavior. But my question is, what does it actually mean for user NS to map project ID? Because if I know correctly, there is no concept of current project ID for the process, right? So what is the meaning of mapping project ID to user NS?
Yeah, so you are right that there is no current project for the process. And I just, well, honestly, I don't know what's the meaning supposed to be. I just know that the mapping exists there in the structure. And we apply it at times. So like, yeah, we can just probably remove it if we think it was a mistake and it doesn't make any sense.
After the fact, after the fact that it's been done, in the proposal we said, okay, if we map a certain range of project ID to a certain user namespace, then this, in the new semantics, that will allow this user namespace to set those project IDs. But like a one-to-one mapping even.
So I think the reason why there was an attempt to add project mappings was essentially if you want to be able to make nested containers work and you are trying to control usage. And, for those people who want to be able to have a distro that supports containers and then be able to run that distro inside a container, I think that was the goal for why they wanted to add that sort of mapping, because there's this concept of you give the top level containers a wide range and then the nested container gets a smaller range. So I'm not the container expert, but that's my understanding of why it was added. I think the higher level story is there are a whole bunch of questions over, access control on who's allowed to change projects, what should project inherent flag, who can change project inherent flag, and how do we set the new semantics? Probably via a mount option, but we already have a lot of confusion because there are people who expect that it worked the way XFS supported it on SGI. And I think before I, as a file system developer, make any changes, I want to make sure we're all on the same page about what the semantics means. And I think that's what we were calling on the community for help with, is what is the semantics that we might want to add as this new alternative that probably presumably would be triggered off of a mount option or a process personality, a global flag of some kind, right? That's sort of the higher level question.
I think we don't really make as much use of project IDs as you would expect. Probably if we want to limit disk usage and space usage, we mostly rely on, I guess, file system specific implementations, but I also have honestly no super clear picture in mind how project IDs would be used to limit space usage. We do, for example, use Btrfs quotas. We use XFS has a specific project quota implementation that is orthogonal to the generic VFS implementation, right? Or am I thinking wrong here?
Yeah, but like the implementation is separate, but the IDs are the same. Yeah, so the project, if you use XFS project quotas, then you use these project IDs.
Yeah, and ext4 has tried to use the same semantics as XFS project IDs just to limit confusion, even though we are using the generic quota implementation with a separate inode to store the project IDs. So the goal is to actually keep the user visible interfaces the same, so that there is no confusion between ext4 XFS as much as possible. So that's the goal anyway. And yes, this is different from Btrfs subvolume quotas, but we're trying to limit differences between file systems as much as possible.
Yeah, sure.
Okay, we don't have much time until the next talk. Maybe I'll iterate with like 2 sentences the proposal that was posted on the list, so people so people can understand what are we expecting. I'm not talking about old semantics. I'm just talking about new semantics that are maybe they're usable for containers. The idea is just you want to start a container. Its backend store is a directory or subdirectory tree. So you want to assign a project ID that is unique for that container, and all the files inherit this project ID. And this is what you get. That's the usage of the container. And you cannot set the same project ID in another container, because today you can, and then impact from another container or from the host even on the usage that is observed inside this container. Essentially, we want to make, there was a proposal to make the project ID behave like connectable and unique subtree in the file system, which is similar in several aspects to Btrfs subvolume. It's a much less than a subvolume in isolation, but as far as quotas go, it's similar. That's the idea. Okay.
I have a feeling we're going to have to take this to the FS Devel list, but I think the goal was to tee up the question and make people aware that there was a question here.
Yeah, and by the way, I understand now the rationale behind mapping project IDs. The rationale was just about dividing the namespace, the project ID namespace, because project ID management is done by user space. It's done by user space through etc project IDs and stuff like that. So you wanted the system that's running inside the container to think it has a range, but it has nothing much to do with the kernel, though. So.
Yeah, sure. I guess let's give space to the next talk. So thanks for the discussion, and let's take the more discussion to the list where we can hopefully arrive to some conclusions.
Yeah, I mean, I have a feeling as a last word on this discussion, because hey, I'm running the next one, so I can talk into it all I want, I guess. I think, as I recall, the last time we brought any of this up, the biggest problem we ran into was Dave Jenner saying we need to have a public specification for how new project quotas are supposed to work before we start tearing into the code. I mean, I kind of suspect that mostly what we need is, well, first of all, we probably need to fix XFS to actually do project quota ID mapping properly, because we don't, and ext4 and I think F2FS do, so that's yet another difference. And we also need to solve the question of how does the sysadministrator say either you get new project quota behavior or you get the old IRIX ones, which might just be some crazy XFS thing because, hey, we already do have a bunch of mount options for do this weird IRIX thing that someone invented when I was in high school. But sadly, I don't think there's any real public specification for how the old IRIX ones work. You kind of just pick Dave's brain.
Do you have any slides that you want to load, Derek, or should I just?
I was just going to, for this session, I was just going to review some man pages that I wrote.
All right.
So, on to the topic of, it is after 8:30. On to the topic of atomic rights. So this is something that keeps coming up in our internal discussions at my employer and also variously on the list. There are two different things that people call atomic rights. One is where you get the hardware to do all of the heavy lifting for you, which basically means that user space, if it were ever able to take advantage of such a capability, would have to have some way of plumbing a IO flag from user space all the way down to the block device. This has been kind of discussed by Christoph Helwig at like several previous LSFs. about we could add this flag, but then he kind of veered off of that topic and hasn't come back to it. And like supposedly there's hardware support in NVMe, although I have no idea if there are any real hardware that implement it. But yeah, let's see which one of these is screen sharing anyway.
Would this be atomic buffered writes or atomic direct?
For hardware support, it would have to be atomic direct writes, since I don't think there's any particularly sane way to plug that into the page cache and through write back. So let's see. I will share my terminal page. So for this, it becomes a simple matter of adding another flag to pwrite v2, or insert the IOU ring equivalent there, and that's half the battle. The other half, which is not really, which I haven't really thought a whole lot about, is how does user space figure out that a piece of hardware actually supports atomic write capability, and in what granularity, and what page alignment and stuff like that. There's a bunch of, I was digging through the NVMe specification and found a bunch of numbers that could be exposed through sysfs, but the hard part about exposing them through sysfs is that then user space still has to go figure out the mapping between here's an open file descriptor and what device does this actually map to. Now, I suppose you could actually extend the XFS DIO info ioctl to actually report these kinds of things. Or equivalently, we might just add them to statics. So that is a potential, that's a potential way to do it. But of course, the hard part is that I don't really want to work on any of this until someone actually gives me a piece of hardware that does any of these atomic write things. So that gets me to the next point. There's a second way that you can do atomic writes in a file system, and that is if you make the file system do all the work. So last year, no, 2 years ago, sorry. Last year, I forgot last year. 2 years ago, I proposed a new ioctl called FI exchange range that you can use to implement buffered atomic writes through the page cache or not. Wherein the strategy is you open a file, you ref link the changes to a temporary file that you also open, make whatever changes you want to the temporary file, and then you call this thing to say, hey, swap the contents when they're different. And the assumption is, well, the requirement is that the file system should be able to restart the operation if it fails midway through, such that if the ioctl call returns 0 for success, then you are guaranteed that that the contents will have been swapped, and that you will always get that even if the system crashes. Audio clipping, yeah, sorry. Up too high. So yes, as David Howells commented, it sounds like compare and exchange for files. And to a certain degree, yes, it is. So what we see here is that we have enough data encoded in the struct parameter to tell you which files, which ranges of files, a bunch of flags, and then this other stuff down here. Now, part of the reason for these things existing is partly a legacy of where the system call came from, which was the old XFS extent swap ioctl, which was used, it's used extensively by the XFS defragger, but essentially what it allows you to do is implement a way to say, hey, I snapshotted this file at this point in time. I then made some changes to it, so swap the extents, but only if this other file hasn't changed since I snapshotted these details, where the details are inode number, modification time, and change time. And I'll get into that a little bit later. So flags. So there's a bunch of flags that I've come up with so far in talking to people about what could we do with this strange new call. The freshness flag is the thing that turns on those fields above, the inode number and the C and M time changes. So this effectively allows you to say, I only want to swap these contents if the file hasn't been changed since I took the snapshot. Let's see, there's some other things, other operational things in here like exchange to EOF, where we ignore the length parameters and just say, I want to swap the entire content starting at this offset. Let's see, there's another one for fsync that just says flush all of, or persist all of the data and metadata to disk before the operation completes, so that we, so that if you have really, really strict requirements about when things appear on disk, you can do that. Let's see, up here. Continuing along, we have, I also added this weird flag called skip file one holes. And this is how I tie this new system call back into the original complaint about not having hardware. See, I had thought it might be useful to construct atomic writes over the loopback device as kind of a toy way to define an interface that can be implemented and tested in software. Because I don't really want to have to depend on having a piece of hardware, because that's kind of difficult. So here's the thing, here's the knob that enables me, or would enable me, to actually do this with the loop device, where for a write to a given loopback file, I could create a temporary file, write just the block level changes to it that I want, and then tell it to exchange the contents, but only the parts of that temporary file where there's actually data written. And so in that way, we could actually, at least for the software implementation, advertise the fact that we support atomic writes on any particular granularity or boundary, because we don't care, because it's all software. Let's see, moving along, I also decided to add a dry run flag that says, do all of the verification and checking that you would normally do to perform a swap, and then bail out if successful. The reason for this is because I found it difficult to write test cases wherein we would actually detect if this thing is available, and does it act, and given the parameters that we want to test with, will the file system give us any chance of actually doing that? So the dry run flag here exists as a way to check that from FS tests, or just generally if your program wants to know, can I do an atomic extent swap without actually having to create a bunch of phony mockup files and try swapping them and hope that that's an adequate proxy variable for will it work with my real files. Let's see, and finally the last two, exchanging full files, where we actually do a bit more checking once we've locked the inodes to make sure that the length parameters are set properly. That one is also a throwback to the original XFS extent swap ioctal. And finally, there's this one called non-atomic, where we relax the requirement that the file system be able to complete the operation even if the system goes down. This also is intended for the other use case, which is file defraggers, where in theory you verified that the contents are the same. You might use it with the freshness check. But you don't actually require any of the heavier requirements for atomic extent swapping, because you know the extents are supposed to be the same. So if the operation fails halfway through, oh well, too bad, you didn't lose any data. So if you know that if this is the case, then you can use this, because at least in XFS, like adding more log operations does make things a bit more expensive. And why pay the performance penalty of that if you don't have to? So anyway, that's the gist of the proposal that I had for atomic writes. And the thing that I would like to know and that makes LPC particularly exciting for me is, if you're an application developer, would you actually use either of these interfaces? I mean, I've heard from certain database projects that yes, they would totally use atomic direct writes if someone gave them an opportunity, but then we get bogged down in a muddle of, okay, so who's going to find some hardware that supports this, and so on and so forth. But I did wonder, for regular file operations, is there interest in having such an ioctl? For my part, I actually developed this thing originally for use with online FISC for XFS, and then decided that, hey, this could be exposed to user space as an actual system call, which would at least solve the problem of, I want to commit all of my changes to a file, but I want to guarantee that they all actually get there. So at this point, now that I've talked for about 15 minutes, I think I would like to open the floor to anybody else to ask questions, make comments, blame the whole proposal down, etc. Ted?
Yeah, so I wanted to mention that I really like this proposal because it's something that we could implement on the ext4 side as well. And if there were application authors who were going to use it, and unfortunately I suspect we may need to take this roadshow to some of the database folks, it occurs to me that this might allow database authors to avoid doing double or quadruple F-syncs to solve the journal of journal problem. If we could actually get them to decide that this is a good thing and it's worthwhile to implement it, even if it restricts the use case of that particular feature to, number one, Linux, and number two, file systems that implement this ioctl, which I can imagine certain database authors not being super excited about, but others maybe would be willing to do it. So I don't know if we have any database folks on at the moment, and if so, it'd be great to hear from them.
Yep. Dave?
Yeah, I was wondering if this would actually make sense in a network file system thing, and how easy it would be to actually implement one of those. AFS possibly. I don't know about something like NFS, where you certainly need server interaction. It could be quite interesting.
Yeah, I think the trickiest part with the implementation is going to be doing things like the freshness checking, because that means you have to start locking. Somebody somewhere has to lock all the files, probably on the back end, I guess.
Maybe a compare and exchange lease for things that support leases.
Yeah, I mean, I guess going off of the way NFS implemented copy file range and and friends, I can't think off the top of my head of any reason why you couldn't just use the same, the NFS client just forwards this across the network to the server and lets the server deal with whatever issues, and at worst the server just says, sorry, I don't like this, go away.
Yeah, and I guess if it doesn't work on the server, you just return a failed swap error or something like that.
Yeah, there is an error code for, no, I didn't do that because freshness check didn't work, or I don't like these files, or whatever.
But also, does it have to swap size for size?
No. You can
swap and insert, or make the file longer or shorter, sort of thing.
Well, you can't insert random things in the middle of the file, but there's no requirement for the files to be the same length. If you use
fallocate allows you to insert or delete some in the middle of a file and extend it that way or shorten it. So I was wondering if you did that.
Let me see. Well, you can. I'm not sure if I totally understand your question. I mean, you can specify different offsets and end up swapping things from this part of a file then gets swapped to this other higher offset in the file.
Oh, I see. Right. Because I
And
was thinking it's like sort of replace, compare and replace. And if the thing you're replacing with is a different size, it might actually move the file up, rest of the file up or down.
Ah,
I guess
yeah,
I could be
yeah,
insane.
the operation lengths have to be the same, with the one exception of if you specify the, which one is it? The 2EOF parameter, then you're allowed to have different operation lengths because it just says, I want to swap the tails of these two files, and we can sort that part out easily.
Yeah. And seeing what Jeff said about Ceph, that could be interesting. If you wanted to implement this on something like Ceph, you'd have to take account of the fact that bits of file may be on different servers, so you probably have to limit it.
Mm-hmm.
So you can't do a thing that crosses a server or something like that.
Mm-hmm. Yeah, right now there is a separate error code defined for if you try to run this operation across VFS mount points, which I guess would be kind of similar to that.
Yeah.
I mean, technically speaking, there's no reason why you couldn't do that across, across different mount points that map to the same underlying superblock. But, since I get yelled at by Christoph for breaking that, I don't do that anymore.
Thanks.
Mm-hmm. Yeah, recently I've started working on a free space defragmenter for XFS, and I have started to use this ioctl basically as a means for defragmenting free space when reflink isn't supported on the file system, because what I do is basically open a temporary file, copy file contents from the range that I want to free up, and then try to use the exchange range with freshness check to remap the extents from the source file into the temporary file. And once captured there, that space is frozen and no one will be able to allocate it. So then I just hold on to that and just keep going through the file system until I've carved out a chunk of free space. And then I say, hooray, I've defragmented the free space. So that's what I've started using it for, in addition to XFS online repair. Let's see, there's a question, doesn't FID dupe range already cover the file2 fresh use case by checking that the contents are the same? It does, but dedupe is a different operation in that if you ask the kernel to dedupe file A to file B, it will remap file A's storage to file B, but it doesn't map file B's storage back to file A. All it does is freeze file B's storage. Let's see, Ted asks, if ext4 were to implement file exchange range, could we use the defragger that you're working on? Yes. The free space defragmenter largely relies on the getFS map ioctl to figure out who owns what and what is where and which files to target. So you could do that. For reflink aware file systems, I actually add in a separate layer and the new ioctl to return reference counts of space extents so that I can try to target larger and more highly shared extents first, on the grounds that we don't want those exploding. So we really, really, really want to try to land those as one big extent. And, for ext4, which doesn't support reflink, I think you could dispense with the getFS ref counts ioctl, because you know that either it's free space or it's not, and getFS map will tell you about the free space. So it should be something that we could implement as a more generic VFS level thing. Let's see. Anybody else want to ask questions, lob, patch, barbs, etc.? See, I see some typing activity going on in the chat, but I don't know if it's just the continuation of namespaces and mapping or actual questions about this particular topic. All right, well.
Hey, Eric.
That's
So,
hi, Amir.
can you say a little bit about the things that would overlap between this API would overlap from hardware support for atomic rights and software support? I wasn't so clear about this point.
Yeah, the reason why I brought both of these topics up in the same session is that they have got. I found that the two have kind of gotten confused because they're both called atomic rights. Hardware atomic rights through direct I/O to a block device is mostly a completely separate topic. That is, which is fortunately one that we could probably simplify down to. We plumb a few things through the block layer and tell the block device it's its problem to go figure that out. The file exchange range thing is completely software based in the file system, and while it could be used to build a software implementation of block device atomic rights, that's about the only real link I can think of between the two of them.
Right, from the user's point of view, they accomplish the same thing, right?
Mm-hmm.
So shouldn't we just create the API that the user wants, and then it could be implemented by software or by hardware?
Yeah, but I don't know how many application authors really want to deal with direct I/O. You know, there's a fair number of people who say things like, well, could we just, it would be really neat if I could just swap these things. You know, they're basically just, right. Basically, it's kind of like the text editor use case where I want to write a blob of stuff to disk and then atomically swap the contents, and I don't really want to know too much more about what really goes on underneath that. And right now they have to use the whole thing of write it to a temporary file and fsync the files and then do the atomic rename and then fsync the directory, and more often than not people don't do it correctly.
Yeah.
I mean, the other advantage of the software implementation, as I kind of alluded to, is that we wouldn't have any particular alignment or file size or scatter gather list restrictions like a piece of hardware would. Like if you wanted to, you could write an entire 8 exabyte file and say atomically swap the entire thing. It would take a while, but unlike hardware, where in past LSFs, the storage vendors who show up say things like, well, we could probably do it, but you'd be limited to, say, you know, no more than 64K at a time, or you can only do, you know, you can only have a maximum of 16 elements in the SG list and things like that. And, you know, if your software is willing to use direct I/O and knows about all of those little details, that's great. But also I suspect that a lot of authors, application software authors, don't really want to know about direct I/O.
Yeah, this was the problem at Fusion IO. We had atomic write support in the Fusion IO drives, but it was limited to 100 or 128 slots. So like you could do max of like 64 megs at a time or whatever. And at that point, it's like, who fucking cares, right? Because if you're writing an entire log, it could be relatively large or whatever. So.
Yeah, I have heard some vague mumblings from certain small software database project or smaller one that my employer's own, cough, cough, that this would, at least in concept, enable them to turn off all the write-ahead logging and stuff like that. You know, no one's tried it yet, so who knows if it really works. But in theory, you could at least get rid of the multiple levels of journaling logs and stuff like that.
Yeah, but like it's the use case is so fucking narrow, right? Like things like RuxDB wouldn't be able to use this because they write huge amounts of, long time. So it's like useful for one guy or two who want to go through the pain and then have to do all of the work to like, what does my device support? What is the limits and all that shit? Like it's just sucks.
Mm-hmm.
So I actually have played with this a little because it's actually possible to create in the Google Cloud environment a pseudo block device that has a 16K physical sector size and a 4K logical sector size. So if you do 16K aligned writes, it's guaranteed to never have a torn write. And if your database can significantly support 16K block sizes in an efficient way without needing to do double buffering writes, like I believe MySQL does, it's possible to optimize that path. The hard part is without plumbing in a whole bunch of stuff in the Linux block layer to make sure that in the Linux block layer and at the device driver, we don't tear the writes. Say, if you have a metadata write that's tacked on to data blocks write, that they don't get torn in interesting ways. It's really, really tough to do. We actually tried auditing an old kernel to make sure we could actually guarantee that. And we did get better performance, but it was a hell of a lot of work, and figuring out how to do it in a generic way was more effort than it was worth, and we kind of dropped it. But in theory, it can work, and there's at least one major open source database where it would be effective, but it only works on Google Cloud because we're the only ones who had the 16K logical physical sector size thing. And so it would probably be hard to get the application stack to actually take advantage of it, which is the other reason why we kind of dropped it. But if there was interest, it is possible to go there. It's just, it's not clear it's worth it, as Derek said.
Yeah, I mean, I have heard through secret murky back channels that a lot of the major cloud vendors these days, cough, 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 support some ability to atomically persist large chunks of data somewhere between 16 and 128K. And right now they enable this for special partners, which is to say people who they've told this to and know that if they format their direct IO writes from user space in just the magic right way, it'll work atomically. And hopefully they test that to make sure that's really true and that we're not just lying. But yeah, I think I would rather prefer to bring all of this stuff out in the light. If your device has this capability, you should advertise it, and then we can hold you to it, which, I mean, that might be where the entire proposal completely goes off the rails because no one will want to guarantee that, right?
Yeah, so at least for Google, it's documented, right? If you create the PD in a particular way, it's advertised as 16K physical block size. So it is sort of guaranteed.
Mm-hmm.
And the nice thing about that is that's something SCSI has defined, right? It's just you can't find bare metal devices that have 16K physical sector size. So it's possible for us to go in that direction, but you sort of have to move the entire storage stack along with you, right? So if we could find consensus that we wanted to go in that way, I think we could. The question is it worth it?
Yep. Yeah, so briefly before I get kicked off, there was one last question in the chat about does file exchange range work for exchanging parts of the same file? Yes, it does if they don't overlap.
Okay. We're over time, but Willie has been waiting. You want to ask something?
I don't know we have time for it. No, never mind.
All right. Okay. So Alison. Thank you, Derek.
Mm-hmm. See you in a bit.
Yeah.
Hello. Can people hear me?
Hi, Alison.
Hello.
Oh, I've made you presenter, so if you don't have any slides, just click the next slide. So.
Okay. Yeah, I don't think I need slides. I did. I threw some slides up last night, but that's okay. I don't think we really need it. Okay. So thank you for coming to this micro conference. This is file system shrink. I think most of the folks here are pretty familiar with what it is, and the discussion's been had, but I just want to go over it briefly just to kind of put everyone on the same page, and bring others up to speed if they haven't seen the discussions or the challenges surrounding it. Briefly, file system shrink allows a file system to be physically reduced in size by some specified amounts, so long as there are enough unallocated blocks to do so. This does involve a sort of reconstruction of how the file system currently has its blocks allocated so that they can be stored in a more compact way. This can be a potentially intensive and also time-consuming operation depending on the current state of the file system and how much stuff there is to move. File system shrink is currently unsupported in XFS, which is generally of consideration when you need a large file system for whatever your use case is. So the idea in XFS is you have these allocation groups that enable more efficient I/O across different regions managed by those groups. And so reorganizing these structures into a smaller area is going to require a significant amount of developer effort to implement. I think ext4 has an offline shrink, and we have a proposal to implement a sort of lazy online shrink by basically inhibiting allocations at the end of the file system. So over time, they'll kind of concentrate in the beginning, and then it's easier to resize it at a later time. But it doesn't look like either of them have a fully implemented online shrink. Initially, I had kind of intended this talk to be more about XFS because it has more room for improvement in this area. But I think a lot of these discussion points are really applicable to both. So certainly I'd encourage discussion for both types. So both of these coding efforts are still in progress and still always being completed. So for this reason, it becomes important for us to really consider what the motivations are and what the benefits really are for continuing to pursue this. We want to understand why people want it, how they would make use of it, or if there's simpler tools or shortcuts that we could use to suffice for whatever the use case is. The current workaround for shrinking an XFS file system is basically just to create another smaller file system and then copy the contents of an existing but larger file system into this smaller space. That's not really the same as an in-place shrink, and it has the obvious disadvantage of requiring enough space for both file systems to be there at the same time. But if this works for people, it would be fairly simple for us to add a sort of like a clone utility to the makefs that sort of just facilitates that instead of going forward with a full shrink operation. One of the obvious questions is do people find themselves needing to do the shrink, but then not having enough unallocated space or not having enough space to have both file systems? So someone's asking for slides. I didn't have slides prepared. So I had thrown some up on the conference page last night, but I didn't think I would need them. So I'm just doing this verbally. So no slides. Let's see, where was I? Okay. I think Amir might load them. That's fine. We'll catch up whenever we get here. Okay, so another alternative that I have seen discussed in a lot of threads is actually using FS trim, on a thin provision volume. So the idea is that you would use fstrim to release unallocated space within the file system, which will have the effect of freeing up more disk space, but it doesn't really reorganize any of the allocations or physically shrink the file system. Here we go. Okay, let's see if we can advance the slides. Okay. Just shrink. Workarounds. Okay, we're on thin provision. Oh, I think we have some. Oh, we have some other stuff going on. Oh, okay, that's for atomic. Okay. So yeah, I thought fstrim was worth talking about, just because you might actually get more space back out of it by doing this, because you're not asking the file system to go pretzel itself back into a corner. And that can be, I mean, there's always a risk of corruption, and it might take a lot of time depending on how much stuff you have to do. Whereas trim kind of is, that's kind of a layer beneath the file system. It's a little more transparent. It's faster for the device to kind of a discard. So you get a lot of the benefits without most of the risk. But then if it's not on a thin provision volume, that's not an option. So I mean, one question to consider is, I mean, are most people using it or not? In some offline discussions with other admins, I find it's fairly common. So if that's the case, that quickly starts to look like a more appealing option. So there's that. Next slide here. So another option is protofiles. So in a lot of use cases that I hear about, generally what's going on is that people are trying to make a root FS. Like they'll make a root FS with some structure in it, and then they want to squish it down, presumably to fit into some sort of constrained space, or maybe a flash area or something like that. And so another way to really facilitate this would be to use the protofiles. And the idea with a protofile is that you have this protofile that describes the directory tree or the file system that you want it to create, and you sort of hand this to makefs, and it would sort of just go off and generate it. And so another direct way of creating your tiny root file system would just be to make this another function or parameter of the protofile. So you would generate this, you have it generate a rootfs with the intention of being space conservative, rather than creating a file and immediately trying to squish it. But I mean, again, that's specific to the challenge of trying to create a tiny rootfs. So that's something that is something that could be discussed or considered. Honestly, I think it would be interesting and helpful to know just how much people are looking to shrink their file system. Because if you really only are trying to shave a little bit off, if you only need a little amount, that's something that we could possibly quickly implement. I mean, we won't even be able to just cache whatever it is that we need to move. But if we're trying to shrink it as much as possible, that's more intensive, and we might need the help of more complex features like RMAP and parent pointers to do a more in-depth reorganization in a reasonable amount of time, because that's going to speed that up. So depending on how much users are looking to save, we might be able to deliver a quicker but less intensive feature that can do that. So those are the kinds of questions we're looking to answer with user stories. And beyond that, beyond user stories, we would want to take a look at any kind of error reporting or APIs that we need. One of the concerns that came up in the discussions for this microconference was actually how are we going to deal with statfs? So while a shrink is in operation, we need to sort of inhibit or we need to sort of limit new user block allocations until we're kind of done with all the reorganizing and the reallocating. And so during that time, it's kind of possible for these operations to fail as though the disk were full. Now we could just report that area as quote unquote used, so that people, so that they don't see it as available to use, but then deleting files isn't going to free up space as one would normally expect. So it's going to be a little bit buggy, or just inaccurate, really. But I think it's worth questioning then, how much do people really care about that? Are they really going to be running operations while they're trying to do a shrink? Or is that just not something that people are concerned about? I think that's something that's worth questioning. And lastly, there are other features that we can use to kind of help facilitate developing shrink, like reflink and parent pointers and reverse mapping and things like that, because they lend themselves to sort of quickly reconstructing to quickly reconstructing a file structure. But there's potential performance costs if you choose to use them. Like, they don't really need to, they might not want to turn these features on for reasons other than shrink. So is it reasonable to sort of make them a requirement to do a shrink in the first place? So those are some of the things that we're looking to solve with today's conference. So I think that's a pretty good rundown of what shrink is and why it's useful and the challenges that we're looking to solve with today's conference. And so I don't want to cut in too much time, so before too much time gets away, I think I want to open up the discussion and see what comments and questions and ideas people have.
Hello. So about the use cases for shrink with XFS and X4, this is not really my use case, but it is a use case for systemd, actually, again, so related to what I've talked before, systemd, homed, where the idea is that you also have resource management per user, and you essentially allow to shrink and grow a file system as a user logs in based on metadata that is stored in the user's portable home directory. And they do support this with Btrfs, for example. This is the relevant part from the documentation, for what it's worth. If that helps, I can paste this in the chat. So they provide a slider essentially, and with that slider you can say this is how much space we want to make available to on this home directory.
Okay.
It's at least a use case, and XFS and X4 are explicitly documented at not supporting this.
Okay. All right. So that would be one reason. Got it. All right. Okay. So yeah, user management. All right. That makes sense. Okay. Thank you.
The thing about shrinking is shrinking the physical size of the file system is not necessarily what you need to do in order to shrink the capacity. And the capacity, for example, can be controlled by project quotas. And that's been done already. And also there was another proposal, like an unrelated proposal by Dave Chinner, to just allow reducing the amount of blocks that is available to the file system without reducing the physical offset of the last block. That's another way that's much simpler than shrinking.
All right. Okay. So that has the effect of inhibiting it from growing any more than you might want it to for that case. Okay.
Yeah. So there's a pretty common use case in the embedded world where they effectively use the protofiles approach. In ext4, you can specify the root of the directory and it will just simply copy that directory into the file system that's being created. We're not using a profile. Instead, what we do is we will actually read out the Unix permissions and even POSIX ACLs and replicate them in the file system to be created. The tricky bit, of course, is you don't know exactly how much space all the metadata might take. And so what folks generally do is they'll create a file system that has a certain amount of slop in it. Like say, they expect that it's going to require 50 megs of space for their root file system. So they create a 64 meg file system, use makefs-d to specify the path, copy in all the files, and then they shrink it because they want to make it be as small as possible. And then this is the part that is scary. They will then try to inflate it to 10, 14 terabytes on their NAS box, not realizing that a file system that is created for one size may have heuristics applied by makefs that may not necessarily be appropriate when you blow it up to be terabytes in size. I don't know if that's an issue for XFS. It is an issue with ext4. And I've been trying to train people to either not do that or specify at makefs time that, oh, by the way, even though I'm creating a 64 meg file system, please create this file system as if it might eventually be expanded to be terabytes. And so that's probably one of the other gotchas about the root file system creation case that's probably worth mentioning. I think the other reason why people want to shrink file systems is because cloud devices, they generally charge based on the size of the virtual block device, not how much space is used. And so although FSTrim saves money on the back end, it doesn't actually save money for the customer who's paying for a certain size, AWS EBS volume or Google persistent disk or whatnot. And so those users are heavily motivated to either want to shrink, or the other problem is they create a file system that is 10 gigabytes, and then when the file system gets to 99% full, they will resize it to 11 gigabytes, and then wait until it gets 99% full, and then resize it to 12 gigabytes. And we have another problem, which is file systems generally don't work well when you use almost all the space and then grow it by a tiny bit and then use all the space ad infinitum. And unfortunately, the way cloud companies have chosen to charge space, it incentivizes bad customer behavior. So that's not directly related to shrink, but it's why some customers will want shrink and FSTrim isn't sufficient because of how cloud companies happen to charge for block devices. For better or for worse.
Okay, that's a really good point that I had not thought of. Oh gosh. All right. So yeah, okay, cool. Thank you for bringing that up. That's a really good reason why that's not quite an option.
Yeah, one use case that Eric Sandin at Red Hat has pointed out is that there are some people who want to convert their computer to using something like dmcrypt and need to cut the last, well, whatever the LUKS header size is off the end of the file system so that they can resize things and stuff that in. So those use cases, you need to be able to cut 8 megabytes off the end of the disk or off the end of the file system, but that's it, which is good because some people say things like, could we reduce this to like 10% of the original size?
Okay. All right. Okay. Well, I mean, that's something then. I mean, that's something we could look at.
As for StatFS issues during a shrink, I tend to take the view that the sysadmin is supposed to coordinate or should be responsible for coordinating shrink operations with the users of the system. So if all the space goes away because you're shrinking it and those programs hit space and crash, well, that's kind of on the sysadmin and the developers for not working that out before they started the operation, because ultimately, if the shrink succeeds, that space is gone and never coming back.
Yeah, yeah, I agree. I mean, there's lots of reasons that you get disk-full errors. It's not just maybe you're out of space, maybe you made too many files, maybe you're shrinking right now. So yeah, I tend to agree with that. It seemed to be something that people were kind of concerned about during the review for this microconference. But yeah, I think that's just an area that we're going to kind of accept that it's just a corner case. But you can't really reflect the end case until we get there. Be patient.
I mean, that might also be my rogue way of saying, why don't we just punt that question to user space and see if they start complaining when the bleeding edge tester people start using it.
Sure.
Or I guess journal D gets the wrong idea about how much space you really have in the file system and eats it all up.
Okay.
Yeah, I mean, we've been shrinking Btrfs, online shrinking Btrfs since day one, and nobody's ever bitched about it. So I don't suspect it's done.
All right. It has the same behavior though? It's that?
Yeah, you use statfs and it shows you the new size. It does all the operations to do the thing. If it succeeds, it's permanent. Otherwise, it undoes everything.
Got it. Okay, so this is kind of something that people are already used to. Great. Okay.
So I have a question. It seems that in order to shrink, I mean, the terminology we can use is that we need to migrate files to lower blocks. But in other migration, like in memory migration, or if you look at DM snapshot, I think it has this feature where if you start writing now to a file, it would write to the migrated location while the file is being migrated. That is a complexity that I don't think that we've mentioned before.
Okay. Yeah, okay, I'm gonna write that down.
Like if you have an open file, I know just you want an offline replicate things.
Right. Yeah, so that'll be something we have to think about going forward, is how to deal with that. That's a good point.
Sort of a reverse atomic write or something.
Yeah.
So that's similar to the problem I'm sure Derek has been looking at in terms of when you're trying to do online defrag. How do you deal with the fact of a file that's being actively written to, especially if it's ODirect writes, right? And so that's why File Exchange has to do the atomic, check of the timestamp, and it's the same issue, right? It's just in online shrink you have the advantage you're doing it in the kernel. But you might have to lock out ODirect writes while you're doing part of the migration, etc.
Okay. Okay, so maybe that's something we can borrow here.
Yeah,
Okay.
my free space defragmenter uses both of those strategies. If the file system has reflink enabled, it will, and fsmap, it will try to figure out who owns the space, clone a copy of it, and then it uses, what does it use? And then it will make another copy of the data somewhere else at a lower block or wherever, and then it will try to FID dupe range all the owners of the old block to the new place.
Okay.
All right. Why would you have to disable ODirect while you're shrinking?
Well, for free space defrag, we don't.
I was just confused.
Well, you would have to while you're actually migrating those blocks, right? You don't have to disable all ODirect writes, just when you're moving one inode or a group of inodes, ref-linked blocks, you have to do that.
Right.
It's a pain, right? But it's doable.
Yeah. In my head, I'm like, you just write to the new location, because as you're migrating, you get cowed. So, but that's just me. My bad.
Yeah, I mean, I think it should work fine to just play around with, basically to abuse copy on write and reflink, so that you don't so that unless you're actively moving except for the tiny amount of time where you're actually moving the mapping, you don't actually have to shut anything off. And you'll see this as like little tiny ripples in system call latency while this is going on, but like you were going to pay that cost regardless.
Okay. All right. Well, great. I think we have some good user stories and some good ideas about how to deal with some of this.
I did have a short comment about protofiles.
Sure.
So a long time ago, I wrote a dumb little script for ext4 that would guesstimate these amount of space you would need for a file system given a directory tree, and then feed it to MKFS to generate a file system image of about that size that would be more or less full in order to create a minimized image. There are tools in XFS progs that can do the equivalent thing. None of them are tied together in one coherent program that just does all of the pieces. And the space estimator thing regrettably assumes XFS version 3 format and seriously needs some updates.
I see. Okay, so that's kind of already sort of started.
And someone probably should write a protofile. Well, I should probably get around to posting my protofile generator, which led me down an interesting dark rabbit hole of discovering that the XFS protofile format is 48 years old. It is the same format that was listed in the MKFS man page in System 5 Unix in 1973.
Uh-huh.
So part of me is really hesitant to touch any of that because the last time I tried, Dave and Christoph said, "Oh, just rip it out of XFS entirely." And I say, "Well, why don't we? Since this is a surprisingly ancient part of the file system, why not just leave it?"
Sure.
But I kind of feel like, practically speaking, we might want to switch that to MKFS-D like ext4 has, where it just walks the directory tree and puts the files in the file system and skip the protofiles.
Uh-huh.
Since as far as I can tell, no one uses it.
I see. All right. Well, maybe that's something we could look at too then. Okay.
All right. Thank you, Allison. And we're on time, and we may have our first break now.
Right.
So we'll take a 15-minute break. I'm going to put this break slide. There's a feature now that the organizers promoted to use the breaks to take a poll when you're coming back from the break. So maybe you'll try that. I don't have the break. Oh, yeah, here it is. Hi. So, according to the poll, there's 17 people back from the break. I don't know if this poll is correct, but whatever, it's time. And hey, only one guy didn't come back from the break, so. Right, Derek. Your presenter.
Hooray. So I guess we've entered the Derek whinges about random stuff part of the program. So this session I actually have no slides for because it started as a conversation between Ted and I on the XD4 conference call about bad storage. And what I mean by that is that now that a lot of people are transitioning to cloud environments, we're discovering that cloud storage has somewhat different failure modes than traditional direct attached storage. And people are may not be entirely familiar with the strange ways that cloud storage can fail or act up or do other strange things that they're not expecting. And that, well, as Scotty said, the more we overthink the plumbing, the easier it is to stop up the drain. So I wanted to have this session to spread the word and also ask people about certain file system management things relating to bad storage and what, if anything, we could do or should do to try to improve that situation. So I don't know if, Ted, you have any particular introductory remarks that you'd like to make?
I actually had 2 slides that I'd thrown together. I don't know if you saw that. Do you mind if I just put them up real quick?
Nope, go ahead.
All right, I'm just going to grab presenter if you don't mind, and let me just throw them up. Upload. Hang on a second. Yeah. And right. So the main observation here is that a lot of us file system developers, as well as application authors, are used to using standard HDD and SSDs, and those devices have spare replacement sectors. So when they find bad media and you're writing to them, they tend to just automatically remap to the replacement sector. And the net effect of that is writes actually rarely fail unless it's a catastrophic situation. Like, so the hard drive explodes or the firmware panics and, you know, the device falls off the bus. And the reality is not all storage devices behave that way. And this is not a new problem. iSCSI has been around for a very long time. And with iSCSI, you could have a single write fail and other writes before and after that are happily succeeding. You know, if you have a RAID array, you could have the same situation where a write to one disk fails and there isn't a fallback, and so writes to other stripes succeed. As a result, I don't know about XFS, but in eXD4, we've actually been getting patches from other engineers at other cloud providers who have been finding that it's useful to make the file system more robust to these sorts of situations. And we've actually been getting a bunch of patches from some of our Chinese colleagues to fix up making the file system more resilient to metadata write failures. But the thing that occurred to me, and this is what I was talking to Derek about, is metadata blocks are like 1% of all the data writes that happen on a file system. What about all the data blocks? And does anyone want to bet that all of the application writers are actually correctly handling failures caused by, you know, maybe they're not checking the error returns or whatnot, or they never actually test the error paths, because most of the time when a hard drive fails, it fails catastrophically. And so these were some of the questions that I think we might want to use as starting points for the discussion, which is, if we can't trust application authors to actually do the right thing, what should we do instead? And one option that crossed my mind is maybe there should be an option so that sysadmins can request that data failures get treated like file system errors. So you shut down the file system, remount it read-only. Maybe you force a reboot so that we can fail over to backup servers if you're doing some sort of high availability system. And if that's the case, how do you specify that that could happen? And should it be like specific to a file system, or should we try to have some kind of general way of doing this across multiple file systems? And we could do that using mount options. One could imagine attaching an eBPF program to the mount point, and maybe we can even give the EPF program like what inode number or the UID of the writer, so that maybe we have different policies depending on the sort of failure. Maybe we use some sort of FA notify scheme like we've been looking at with FS notify for metadata errors, and extend that to data errors, and then make it be a user space problem. There are lots of different choices here, and the question is, what would actually be useful to folks? So those were my quick intro remarks, and I'll turn it over for other folks to comment.
It's funny that you say if we can't trust applications to handle these failures correctly, because from my point of view, we can't trust file systems to handle these failures correctly.
Yeah, so I spent a good bit of time getting NBD to work internally on production with, for thousands of containers that run across network block devices, and like, holy shit, dude. This made me want to push everything to user space and never do file systems in the kernel ever again, right? The kernel does not test error conditions, which is part of why I did the BBF error injection stuff, was to find bugs like that fell out of the NBD stuff. Like, it's the integration, like how tightly integrated we all are to everything. Like, we can't handle failures like this. Like, the best option is to just like fuck off and try again later, right? Like, this is a huge problem, and is not just like a, hey, let's develop these interfaces. Let's like, hey, let's make sure we can even handle EIO in any case at all.
Yeah, so I went to talk to some sysadmins about what do you do with errors, and I was talking with one guy who had a fiber channel array with a slightly dodgy connector, and when he saw a burst of file system errors on the console, he'd go wiggle a cable, and then everything carried on, so everything was all right. Yeah, and I had to tell him about how no, that wasn't right. And I know Jeff's giggling because he can see he and I have been over this a number of times with the write back errors, but yeah, these write back errors are just completely invisible. The page never got written back, but we marked it up to date in the page cache. We marked it clean in the page cache. It was like we just threw away the user's data, and it's freaking terrifying. So at this point, I've actually got a proposal. I've only done the barest of prototypes of this, that device errors don't even go up to the file system. We just freeze the file system and wait for the user to say, oh, hey, I've jiggled the fiber channel cable. It's okay. We can now we can retry the IOs and then let the file system resume. And I don't know that's a bad idea even.
Yeah, funny you should mention that. So you know how the kernel community is getting this bad reputation for, oh yes, I love your patch. Now can you go and rewrite this entire other subsystem? So I kind of led Xiang Yuan down that garden path with DAX, because they're trying to solve the problem of what do you do with hardware poison coming from persistent memory. And I said, well, we should really just have a generic callback thing to go up the stack for the media failed in your PMEM block device, whatever. And now we're going to force the file system to actually deal with these things as they happen, instead of now where it's like, well, XFS has no idea that your data write just failed. And this would have the advantage that at least in XFS land, we can actually consult the reverse mapping index to find out which parts of which files or metadata or whatever actually failed. so that we can either send the magic notifications to user space of, hey, you lost this part of a file and you should expect an EIO at some point and do something about it, or not. And for file system metadata, if we have it cached in DRAM, we could just write it back out and hope that writing the disk will actually solve whatever the problem is. But then it got kind of shut. That whole thing kind of got stuck in the hell of Christoph shouting over all of us. I mean, to be fair, you know, I could probably fill an entire week's worth of conference tracks of, here are all the ideas that Christoph has shouted about over the years, but I still think we should do anyway.
So I think that we're probably not going to be able to get a one-size-fits-all for this sort of thing, right? You know, I think we're going to need to have some sort of selectable behavior with the same default. You know, that's probably what we're going to have to aim for here. And I think we don't want something that is file system specific either. I think we need to do something that is works correctly across file systems in the same way. That's my basic input on this.
Yeah, and I think that was a key part of what I was asking for was I do think it ought to be something kind of standardized, and whether we do it at the block device or at the file system layer sort of depends on what kind of granularity you want. Because, you know, in the cloud environment, you're not going to be able to jiggle the fiber channel connector because that's not what's happening, right? It's some sort of software defined storage thing. You know, in some cases, it's because the data center has lost power, and in fact, killing the VM by whatever is the fastest means possible so you can fail over is in fact the right answer. And so it's very, very dependent on, you know, such things that only the sysadmin would know. We have no clue as kernel developers what's right for a particular use case. So the question is, how do we specify that policy, and how do we make sure it's general enough for various use cases that we haven't thought of yet?
So I think for this is like it starts with like what Willie said, is just proper error propagation, right? You know, for us when we did this internally, it was, you know, instead of like having all these magical things about like, hey, was this data, or do we care about metadata or whatever? Like, it's just fucking tell the application that, hey, your data write failed, and then the application would be like, I don't give a shit about this data write, or I'm going to do something about it. And then for metadata, right, like we vastly prefer that you just, everything goes down, right? If a metadata write failed, there's no way the file system is going to be able to recover appropriately. We had like all sorts of things where we like try to remount read write after we did everything. No, the file system never does the right thing here. It's always just metadata fails, we nuke the whole thing, the application falls over, and we go straight into the recovery phase of tearing it all down and rebuilding it back up. And it's got to start with, you know, error injection or something to make sure that all of the paths all the way up to user space are doing the right thing. When we get an error fucking anywhere below the file system, it goes all the way up into user. So if that's on the right, you know, if it's at a write and it's a buffered write, you get it at the fsync. Otherwise, you get it at the close, or you get it at, you know, the problem here is that the case where you close and the write happens well after, well, wouldn't we just assume that the user space didn't care, right? It doesn't matter. And bubbling that up to the sysadmin, that might be relatively helpful, that particular case. But really, it's got to start with making sure that we even get that fucking error up to user space in the first place, which, you know, having fixed a fair number of hangs in every file system, and like cases where we just straight up didn't do anything under error, like, dear sweet Jesus, like that's got to be the first step.
Yeah, I mean, I completely agree we need to do better at error propagation. I think my concern is, even if we propagated it up to the application, now we're stuck with, does the application do the right thing? And we've bubbled it up. And so therefore, I'm actually suspecting that in a bunch of situations, the right answer is you tear it down by panicking the system, right? Just kill the entire system, let the HA system, you know, fall over and take it over at the higher level. And, you know, the advantage of that is that's something we could code, right? And if the sysadmin turns that on as the desired policy, it fixes it. And sure, we should, bubble up errors to the application and then hope the applications are checking error returns from close and fsync. They all do that, right? But I guess I'm much more pessimistic, and I suspect the right answer is just, in many cases, just kill the system, right? And then, I think there is no one size fits all, but that is, I think, a solution we should seriously consider for at least, some scenarios.
Yeah, no, I agree, right? Like, this assumes that user space does the right thing, which nobody does the right thing ever, fucking ever. But I think, as far as adding complexity to the kernel to do like magical things to like give user space more information, nah, fuck that shit. Like, the user space is responsible for their side, we're responsible for our side. If we did the right thing and we're propagating the errors, then it's up to user space to do the correct thing. I think that adding a pessimistic option to say like, hey, listen, kernel, if you ever encounter an error, just bring the whole thing down. I think that's reasonable, right? Especially for, you and me, right? Where we don't care. We want the thing to go down so it can fail over, right? I think that's reasonable. But doing anything extra fancy, oh, God, no, please no.
Actually, I disagree. As someone who uses Linux on the desktop, I want a chance to plug my USB key back in. Because I happened to unplug it a little bit too soon without waiting for the sync. Like, pop up a notification on the desktop and say, hey, dumbass, plug your USB key back in. There was data that you hadn't written to it.
Yeah,
And
but
with
components for all of that to work, though. Like,
Oh, yeah, I know. I traced it through. There's a lot of things got to go right for that to work.
And it's funny because I think the places that can manage the complexity of having the kernel do something really smart are also the places that are like, make FS is my FS check, right? And so at some point, I'm not sure that complexity is what we want to engage our time and energy in, outside of like actually bubbling the errors up so that we can, shoot the file system in the head really quickly. Other than that, I wouldn't invest too much.
I mean, I don't think, in Willie's case, right? I think that sort of behavior would be simple in, like, if we stuck it at the block layer spot. Like, we say, okay, you don't actually perpetuate errors, you just don't claim it completed until we're successful. And that way the file system doesn't have to be smart enough to handle everything. It just hangs, and you unplug the thing and it goes, hey, asshole, plug me back in. I'm stopping all IO to this thing. You plug it back in, it does the IO, and then you're good to go. I think that's a reasonable thing that wouldn't be too complex, but like moving the intelligence into the file system is a recipe for sadness and even more swearing for me.
Yeah, I mean, but I think we do need to have like some consistency across file systems too. Right now, it's really inconsistent. Some of them mark the page clean. Some of them, will redirty it. It's across the board, right? You really have to know what you're operating on in order to be able to do that. And the problem too with just shutting things down when this happens is that we get network errors all the time in network file systems, and I don't think that's really feasible there. We have to have something that's a little bit more robust.
Yeah, I think that, I think that is towards my proper error handling thing, is like, we have to have like, okay, this is the thing that happens when you get an error, right? And everybody's consistent, everybody's clear on it, and we test it to make sure it does actually work, because that's the problem, is like, nobody tests it. We all think it works, but it doesn't fucking work. And then having like a clear thing for retries. So like ButterFS can technically, like, if something fails, it has multiple disks, it can rewrite or whatever. So like having a blessed way, or same for network file systems, have a blessed way of saying like, okay, if you were capable of retrying or whatever, this is the thing that you do, and we all use this thing, and again, we fucking test that thing to make sure that it continues to work in all cases.
So I noticed Florian had raised his hand. Does that mean, Florian, did you want to say, raise an issue? No.
Yeah.
Go.
So I was wondering, we currently have a gap in the user space interface. So if you don't want to do fsync in like shell scripts, cat, grep, whatever, and you don't want to do an fsync on standard out at the end of the process because performance will be really bad. But what you still want to check is that the pending writes have storage allocated for them, so that you don't get an space error later in the background. And we currently have an interface for that except close, and that's sort of problematic to close standard out just to get the error code. And I wonder what user space should do in this case. Like ensure that you at least have the space allocation. So we're not talking about catastrophic failure, but something that happens all the time if you run out of space.
I mean, like, there's what should happen, which is that the write itself should not succeed if there's not space, right? So that's what should happen. As far as like handling the case and that the file system tells you it was fine and it really wasn't, I don't know what the best choice here is beyond fsync and close, because we don't have an interface for this, right? Like we have all the interfaces in the world for like how does this work normally, but we have zero for error reporting. And perhaps this is where something asynchronous could come in, but like how many applications are going to like actually listen to like a netlink channel or whatever, say like, hey, this thing failed in the background after something was closed, and I just want to let you know, right? We're adding a lot of complexity for a case where the user space may not give a shit. Like if they didn't care about the write, then they should have, if they cared about the write, they should have synced and closed.
Yeah, so I mean, I can imagine scenarios where you have a graphical desktop and you would like to let the user know that, I mean, I guess they sort of get an early indication, or they can, if the DM thin device is getting almost full. So you actually have a chance to do something before you actually get the space handed back from the block device. But I think there are a couple of different scenarios here. There are scenarios for data center servers, and there will be a set of things that are right there. And I think most of the time it will be either kill the instance of the file system and the whole block device, or it might be kill the entire machine. But then there may be other cases such as the desktop or the mobile handset, where it might be that the process that cared is actually different from the application that's actually running. So I do understand your concern about, we don't want to be overly general here, but at the same time, we probably do want to think about a couple of different use cases that go beyond just, the data center server. Because, I can very easily just fixate on that because I spend a lot of time there.
So for the closed case, there is actually an implied interface already. So if you call close on the descriptor, then some file systems like NFS perform the remote allocation at that point. So you know for sure that unless there's a catastrophic failure, the data lands in the remote file system. But I just wonder if that's the appropriate interface. So we duplicate the descriptor in user space and then do the close to get that sort of lazy, limited fsync operation.
You really probably shouldn't depend on the return error from close at all. It's when I was doing a lot of the work to handle write back error stuff, Neil Brown brought up a good point, which is that close is it's not a reliable interface for reporting errors. You need to fsync first. It sucks, but that's the way it is.
Yeah, then the problem is that for tools like grep and cat and all these shell scripting tools, should you add an fsync at the end of the script, or of the end of the program, and slow down your shell script? That's kind of a hard decision, right?
Yeah, I mean, there may be space for us to add some sort of new syscall that's better for this.
Just make a, hey, shit fucked up trace point, and people are going to attach BPF scripts to it if they want. Problem solved.
So Carlos, I think you raised your hand.
Hey, can you guys hear me? A while back when we implemented the metadata retry errors in XFS, at least I think we can actually try to extend that to also user data errors. At least is a way users could enable or disable it on the fly via sysfs. And regarding actually how to report it to user space, the issue with async writes is actually something I'm not sure if there's something we can actually try to implement via that interface too, but yeah, I don't really see a way how we can actually report it back to user space without a new either system call to actually have applications monitoring async writes or page write back writes.
Yeah, the async after close, like the write happens fucking forever after everybody cares about it is like the big problem here. And I think the only option really is to provide some sort of consistent error reporting chain. So, it sounded like I was being glib, but I'm pretty serious about throwing a trace point in there and letting user space deal with it. Like user space now has a spot that they can tie into that we all use if they want to monitor for things happening, and they can use that as a reporting mechanism.
Yeah, well, actually, adding a new trace point is like trying to make user space use a debug interface to actually do error handling. I don't see how it would be accepted upstream somehow.
Yeah, so I think if we did it, my proposal would be some sort of fixed eBPF hook that you might attach to the struct super or the struct block device, and you feed it information through a defined interface instead of a trace point that's subject to change. But that's basically that idea, right? Which is you let the sysadmin define the policy in the form of an eBPF program. I mean, the other thing that's maybe worth mentioning here is the reason why some file systems would just simply mark the page up to date because of an error is because we presumed that it was better that we not let the system get killed by, the killer when writes failed, and we just simply left lots of dirty pages never to be written out again. And maybe that made sense in some scenarios, like the loose USB drive, where the user pulls the USB drive, it really is never coming back, and we'd rather not permanently lose the memory. But it's not clear that was always the right choice. And maybe that's another example where we need to have a well-defined way of saying, nope, if you get an error, we will not mark the page clean. We will mark it not up to date. And, that means the space will be continued to be consumed in the page cache because that's the right thing, as opposed to throwing away the data, right? I mean, people forget that that was actually a conscious decision we made because in our arrogance, we thought that was the right answer. And I think what we're coming to is that's not necessarily always the right answer.
Yeah, I would just note with respect to notification that there is this effort to implement notification about file system errors to user space through FA notify. So currently it's limited basically to the system monitoring kind of use case. So basically, if there is some file system error, either it is IO error or some metadata corruption spotted or whatever, then basically you will get through FS notify an event something is wrong. Yeah, currently it's very limited, but it can be details can be extended, stuff like that. And there was discussion that actually this could be extended to this, later we could possibly extend it to this like asynchronous write back errors notification as well. Like it's also a possibility with FA Notify. The advantage is that it's like relatively accessible interface to user space, and we can do like monitor only separate set of files or stuff like that. So that's also one possibility of the notification interface. Like, yeah, I just wanted to mention it.
So I noticed Florian has their hand raised, and I also note we're almost coming up to the end of our slot. Although Derek, you've got the next session, so.
Just a quick question for recovering user space. I think user space would have to know some sort of crater size, basically the size of the storage unit that may get invalidated by one write, because you might lose more storage around that on a catastrophic failure. Is there some way to get that? Because, for example, PostgreSQL currently assumes that only 8K will get lost by any such failure, and that's the amount of data that can be replayed from the write log during recovery.
I don't think there's any way to get that information out of the kernel.
But user space would need that eventually, right?
I mean, I can say that as a sysadmin type person, I totally want that kind of information to say, hey, so that something will show up on my screen of, hey, stupid, your storage went bad, or the USB fell out, or in the case of this brand new laptop, it overheated and died. And, you know, maybe we can get there, since it's kind of similar to this whole PMEM hardware poison thing too. You know, I don't care necessarily, like, if you decide that we just want the full file system to go offline when the storage dies, that's all both a choice, and I think it'd be fine, but I would like the notification so that either me or system management tools can maybe try to do something about it if you care, since, you know, I'm also trying to push this whole online repair for XFS thing, and it could be useful to know, hey, this is starting to go bad, and or something, and maybe we'll try to do something, or we'll just torch the whole file system. Like, that's really up to the sysadmin, of course. Because, you know, last week when I got this new laptop, I accidentally logged into the wrong machine and ran NVMe format on the wrong NVMe stick, and discovered that, yes, the desktop environment will react to I/O errors, in that the entirety of Plasma Desktop crashed, the screen faded to black, and then the keyboard stopped responding, and I couldn't do anything.
Yeah, so Carlos, I noticed you came on, and then Derek put his camera up, so I'm guessing he has a question or comment?
Then something that just occurred to me regarding this user write errors notification. I wonder if this couldn't be, I wonder if it couldn't be us shooting ourselves in the foot, because one situation that I'm quite sure is going to happen is when we have actually storage errors with, for example, non-battery backup units or something like that, when we don't actually notify the user.
Did you mute yourself? Carlos, you're muted.
Sorry, guys, my cat actually muted me. So I just wonder if we were not going to shoot ourselves in the head and in the foot with this user data errors notification, because one situation that I'm quite sure is going to occur is when we actually lose writes because of storage failures, like non-battery backup units or something like that, and we simply do not notify the application. We actually miss the data, the write, because we actually didn't know we lost it. So we are going to end up with even more file system complaints for things that are actually not our fault.
Yeah, I think that, it's just going to go wrong in all sorts of ways. I mean, Btrfs will throw errors later. Like if you wrote, and like this happened often, is not often, but this happens occasionally where you write to the NBD server and the NBD server had bad memory and you corrupted the thing silently and you didn't find out until you read it back later. Like we can fucking go down a huge rabbit hole of all the things that possibly could happen. This is why I'm really strongly for like making sure that we have a consistent way to make sure that all the error reportings that we possibly could ever do are tested, they're consistent, we have a real system in place, and then we can talk about like how do we tell user space. Personally, my own personal bias is BPF, like we can do things and then we'd let user space make the decision about how they consume those things and like what they do and all of that shit, and we just give them like structs and then BPF can go do its thing. I think FA notifies another perfectly legitimate answer, but having these like a consistent place that all file systems use to say, okay, something went wrong, right? And then when we have one helper that does the thing, and we know that this one helper is used by everybody, we can put whatever monitoring stuff we want in there, and then we can let user space sort out how it cares about whatever different failures and give them as much information as possible to make the decision that they want. And we take the decision making out of our hands. I'm like so over the kernel trying to make generic decisions about things that user space wants to do, because user space is going to want to do something different no matter what. And every time we build the intelligence into the kernel, we end up wanting to change it. We end up in this long ass discussions. And dude, I'm fucking over it.
Dan, did you have a comment you wanted to make?
I was going to say about the question about blast radius and communicating these things. Is the blast radius is usually hardware specific, like poison cache lines for PMN is 64 bytes versus like you get losing entire pages or losing entire disks at once. So it's really going to be hardware specific. But also say about notification and smarts, like the current notification we're replacing is memory failure, and all memory failure does today is send some magic stuff in a signal that fires once, and you have to be lucky enough to be the application that knows how to process that signal and forward it to somebody that can do something smart about it. So having a mechanism for user space to discover things, discover where the errors are is what I think is what Derek's talking about here, and less about the kernel doing something smart with it, because I agree the kernel can't, but right now we have pretty poor mechanisms for even communicating, hey, is anything wrong in my file system? You don't know today. Like the driver knows maybe, but hasn't told the file system. And so that's what we're trying to fix right now.
We already have an internal interface for reporting errors. It's mapping set error, at least for data errors. But the question would be, do we want to plumb in something where it like does an async notification at the same time when those come in? So that's probably worth thinking about.
Well, yeah, I think the kind of from the reverse angle, we don't know the mapping. All we know is that we know sector X failed. We have to reverse map a lot through drivers and device mapper and file systems to figure out, is there even a mapping to this that we could set an error on? Because we're coming at it from the hardware first perspective.
I'll note too that we had a patch for FSinfo before it got shut down and being merged, but it was a way for someone to be able to query the file system and say, hey, have there been any write back errors since the last time, without actually doing any sort of sync. So that was something that might have been might have addressed the thing that Florian wanted. But I'm not sure it's, that never didn't make it in. So we probably would want to think about that again.
The nasty thing about memory poison is that you don't get notifications on writes. You only get notifications on reads. You can overwrite it and still have errors there. But the hardware really won't seamlessly tell you that the write didn't make it. Only find out on read.
I mean, that's true for most storage.
But yeah, it's not true for most storage, but yeah, I'm saying like this is the range of weird hardware you have to deal with.
So I don't know if there's anything more that needs to be said on this subject. I mean, obviously, we don't have we were not going to make a decision here today. I certainly would be willing to try to come up with a eBPF proposal to send to FS Devel. Whether we put it on the block device or on the Struct Super is, I think, one of the open questions, but I don't know that it changes all that much. It really depends on how much information we want to give to the eBPF program, right? If we want to give it the inode number and the path name and all that other good stuff, it probably has to be on the Struct Super. Maybe that's overcomplicating things. I suspect that's a discussion we probably need to have on the mailing list. But I'll take the action item to maybe start a thread. Does that sound good?
Sure. I mean, I kind of wonder if letting people set eBPF programs on anything other than the first original FS mount point is just going to lead us down the rabbit hole of, oh well, now you should be able to do eBPF programs on in these all these other crazy ways of like per inode things, which then just sounds like a giant, huge complexity nightmare in the kernel.
Yeah.
Shrug.
I mean, the thing is, who is going to do what to fix the problem, right? At the end of the day, the user space program, CAT, is not going to do anything to fix the problem. CAT does not care what the IO is. The sysadmin is going to do it. The sysadmin needs to know what block device this is, whether it's the USB key that you just had plugged in, whether it is drive in slot 4 of cabinet 3 of rack number 12, right? There's a lot of information you might need, but I think it's got to start with the block device. I don't think it starts with the super block.
I mean, yeah, I kind of thought maybe we should, I think I'm getting to agreeing that we should just start with the simplest interface of this file system and maybe this inode number and blah. Went bad, and now it's user space's problem to write a management daemon to deal with that and, export the 50 megabytes of XML dump that will inevitably happen.
Yeah, there's no reason for us to make these decisions. We provide FA notify a BPF thing, whatever, and let user space sort it out. Putting this complexity in the kernel, just no.
I mean, honestly, I kind of thought, well, maybe I'll just try to help push the FA notify thing along and see how far that gets us on just here's a notification event, and if you want something better than that, then, well, then come to future LPC and complain about its lack of existence.
So should we turn things over to the next topic, which was the XFS roadmap?
Sure, we're about at 10:30 anyway.
Yeah, that was a good session. Derek, your presenter. Do you have slides for this one?
Not really. I mean, this is kind of I've been on video chat for 4 hours continuously. So I figured this might be a shorter session. It doesn't even necessarily have to be XFS specific stuff. I sort of thought I would start by noting some of the things that are probably going to show up in this year's LTS kernel, and then talk a little bit about stuff we want to do in 2022, and maybe we should open the floor to letting if anybody wants to pipe up about other file system work going on too. Just as a here's where we've ended up at this point, and here's where we might go next year. So, let's see. So I think we speculate that 5.15 might end up becoming the LTS kernel for 2021. And as far as XFS goes, we have landed a bunch of things over the last year and a half that will end up in certain major enterprise distro releases in early 2022, maybe, probably, cough, cough, not making any promises. As far as XFS goes, we have landed support for timestamps beyond the year 2038. So, and we have also simultaneously deprecated the old XFS version 4 format, which doesn't support timestamps beyond the year 2038. So as far as the deprecation goes, we initiated a 10-year countdown. So we will stop supporting that in September 2030, which hopefully will give everyone enough time to migrate all their file systems. Let's see, we also added a new kind of more internal feature called inode B-tree counters, which should improve mount times by caching more things in the allocation group headers. That should be something that we'll just turn on by default quietly in MKFS at some point, and then you'll just notice that new file systems take less time to mount. So that's actually 2020 stuff. As for 2021, we have most recently turned on log buffer write pipelining so that the XFS log can actually write multiple log buffers at the same time, which should improve performance on file systems that are experiencing heavy metadata update workloads. And most recently, I've also finally managed to land a patch set that will defer inode inactivation, aka what happens when you close an unlinked file and you have to free all the storage associated with the inode and the inode itself. So XFS now defers that to a background process that will run. The obvious front-end effect of this is that deletes are now appear to be a lot faster at XFS. And more importantly, it means that background stuff can actually be backgrounded. This is, I think, where we're going to head in the future, to trying to manage run more things in the background when it's appropriate. And we can then optimize things. So for example, the inode inactivation thing, we can kind of do those things in inode order with a batch of inodes instead of starting a bunch of transactions and repeatedly updating this and that and the other thing. We can just say, okay, it's done. Just get rid of this whole giant chunk of stuff all at once. So that's where we are at the end of 2021. As for 2022, some of the bits have leaked out already today, I'm working with Dave Chinner on a free space defragmenter. This may be used, this can be used just to defragment free space, obviously. And we'd like to connect it, as we mentioned in Allison's session, to the ability to shrink the file system some amount. Let's see, and in 2022, I would also like to get back to my online XFS FISC project. I don't know how many people are really going to be interested in it, because I feel like file system failure cases are sort of bifurcating into two different outcomes. One where you say we don't care, as soon as you get an error, just tear the entire system down and rebuild the containers and whatnot from scratch. Or as Joseph said, my FISC is MKFS. I mean, hey, that's mostly mine too. Or the other one where you really don't want to take the system down because you have something special where MKFSing and reimaging will actually be quite expensive, and repairing things online might be a somewhat less bad alternative, or at least trying it once to see if this is a transient IO error or something more catastrophic. So I'll plan to push that whole thing out again at some point, but I kind of wonder, I have long wondered how many people really want this. I kind of suspect it's the super ultra niche case for some certain enterprise folks. But it depends, right? Because Big Iron might want this, and also I want it for that crappy USB key that has all of the pictures from the 1990s on it. Or I kind of want to, if I get re-errors on that, I kind of want to try to repair that before I start digging through all of the horrible boldy boxes in my basement for tape backups and things like that.
Are you asking
So,
about repair or about checking? Online repair or online checking?
Well, more the repair part, because checking is more or less finished in the kernel. So we actually, XFS does have the ability to scrub all of the metadata and file data to see if the storage will cough up any errors or if we can observe any inconsistencies in the metadata. The repair part is kind of stuck in, I actually do have a full patch set to implement that implements all of it right now, but I've been quietly revising it to impose fewer requirements on the client system. There's a lot of stuff that. Oh, go ahead.
I can
Amir.
say that, yeah, for my employer, online checking is certainly something that we're looking forward to using more. Repairing, yeah, it's probably when you know there's an error, you're gonna get stuff out of backup or something. I think that's going to be the way to go.
Mm-hmm. I mean, for me, it's also online repair is a really more of an interesting research project because it has kicked me to use some of my pretty much all of my pandemic lockdown time on researching how do database systems construct B-tree indexes online. So just as my own personal research project, it has been quite interesting, and I don't know if it's really going to end up becoming part of upstream XFS. It would be definitely cool if we had that ability, just to see how many people are willing to use that versus the nuke everything and just start over from backup approach.
Well, it would be interesting. It would be interesting to know like that the errors that we find are contained in several files, and then it's not nuke everything, right? That would be useful, of course.
Mm-hmm. Yeah. I mean, the other advantage that online repair gets us, especially for the free space defragmenter, is that we also have the ability. It also gives us the ability to rebuild arbitrary metadata indexes. So if you need to move a bunch of B-tree blocks, you can do that. And also for things like extended attributes and directories, you can also compact them to make directories even smaller than they already are. So this is a way to, I mean, I guess I suppose that's generally true of all the B-tree indexes in XFS. Like we also use online repair to rebuild things and compact the B-trees so that they use less space. So, it's the sort of thing that has occasionally popped up for ext4 where people say, hey, how come the directory never gets smaller? And I think they're close to landing a feature to do that so that you can at least punch out empty directory blocks without having problems. So anyways, so now that I've talked for 10 minutes, basically, I think I'd like to open the floor to everybody else, especially other file system maintainers. If you have interesting stuff coming up or that has recently landed and want to talk about it while there's at least nominally a bunch of application developer people around, or if not, I mean, we can also
Nobody's picking the gloves.
Mm-hmm. I mean, if not, we can also use the last 20 minutes for additional discussion, since I know that the IO errors thing seems to be continuing in the chat, and there are probably a few other things that have kind of spilled over their time slots. All right, Joseph, do you want to say something?
Yeah, sorry, it takes like 20 minutes for the click camera button to work. Willie, did you want to keep talking about the error thing? Because I don't have to talk about ButterFS. It's up to you.
I mean, I could talk about the error thing. I wanted to talk about a couple of other things that I've got, but they're kind of internal to the files. You know, they're things that affect file systems rather than affect user space. So if we're trying to have an interaction with user space and somebody has something else to talk about, then let's do that.
I think let's do your thing, because I was just going to talk about ButterFS. Shit, so.
So I've got a few things on my mind around, well, actually error handling on read, because most people talk about error handling on write. But on read right now, the page cache is pretty bad. If you have a persistently bad byte and you keep trying to read the page that it's in, the VFS will call the file system one time for each read request that comes in. So if you've got something like a web server that's trying to serve an index.html, and that index.html has an error in it, we're actually going to call the file system each time. And so you can imagine like a 30-second timeout while the drive goes grunt, grunt, grunt. And you're trying to serve 1,000 threads, and they all hit index.html, and so you've got 1,000 threads all just waiting for each other thread to go and make the drive go grunt, grunt, grunt for 30 seconds. So one of the things I want to do is make read page synchronous. So right now, there's two ways of getting the data off disk and into cache. There's read ahead and there's read page. There's read pages as well, but that's on its way out. So read ahead would just throw away errors on read like everything does today. But read page would be synchronous, and it would return you the exact error that really did occur. You've probably not looked through it, but if you go look in the page cache, almost everything becomes EIO because an IO error happened. But actually, we've got a lot more data that can be returned. Block file systems can return any of the block status T, so things like timeout, or tell you whether it was a transport error or whether it was a target error, with a medium error. All this kind of actual good information that you might want to be able to do something with. And so by making read page synchronous, it can actually wait for the error to come back from the block device and then broadcast it to every single waiter that's come in. So we'll continue to do retries as new requests come in, but anyone that came in during the previous 30-second wait is going to get the same error because they're all going to wait for the same error to come in. This is all delayed behind the folio stuff because it's all touching the same code, and I don't want to redo it 2 or 3 different times. But that's something that I'm planning on doing in the next year. There's a few file systems which don't quite subscribe to the belief that they should implement read pages, read ahead. And so those need to be fixed too. Yeah, I know it is as stupid as your IRL makes it seem. I think people have not quite understood the purpose of some of the entry points that we have from the VFS, and obviously that's a documentation problem that needs to get fixed as well. That's one of the things I have in mind to work on in the next year.
Yeah, I think that it would be nice to make this sort of thing generic, right? So we bubble the error status all the way up, and then the generic stuff like keeps track of like whether or not this a particular error is retriable or not, right? So we can shortcut like, oh, okay, the drive is just dead, right? So like just don't ever just return EIO immediately until we have some sort of clearing option. And then making read page synchronous. I mean, it essentially is kind of in practice just because the page is locked. If some other asshole comes in, right? Like
there's swap, particularly swap over NFS.
Oh, you had to bring this up, didn't you, Dave? Yes. Swap makes everything worse.
You asked for someone to try and make it use direct IO instead. I had to go at it. That started a side conversation with Christoph about perhaps there should be other entry points for doing swap.
So I thought we resolved that already, that direct I/O in the address space operations was going to be used only for swap.
Possibly.
And maybe rename it so that it's
But I
obviously
think,
swap
yeah.
I/O.
But it's still used by the generic generic read file, whatever it's generic file read, whatever it's called.
No, it's not.
Or generic file write. One of them uses it.
I thought it all got filtered out at the file system ops layer these days.
Right, it's in the VFS or VM, whichever it is. It traps. It goes through the direct I/O vector instead.
So quickly chiming in, for IO map, it is overloaded already the file system layer, but for those file systems that don't implement IO map, they usually rely on generic file handlers to actually use the direct IO helper in the address space operations.
Yeah, but I don't think we actually have any left.
We do. Like the old style file systems like UDF and ext2, and I don't know how much other, probably VFAT and stuff like that. These all still, I think, use the old helper. At least the code is still in there.
Okay, my grepping has failed me then.
I mean, it's the old direct IO code, so good luck.
I think NFS is the only network file system that actually implements that. The others that actually implement direct I/O at all do it themselves under read ITA and write ITA.
Mm-hmm. Yeah, I mean, that's, I think, roughly what XFS does these days. Takes over. It doesn't use the generic functions and just figures out which IO path you wanted and calls the underlying library functions from there. Also, I have a separate comment for the Matrix chat that's going on right now. So XFS currently has a sysfs thing where you can configure its error behavior for things that it thinks are transient, like EIO, and things that it thinks are space related, like space. And I think there's also another one for things that we consider catastrophic device errors, where like the drive fell out of the machine and it's never coming back. And I would like to offer that as maybe we should elevate that particular thing to the VFS. So as the thing that we do for, what is it? As the real proposal for /sys/fail forever on EIO. Like basically, we already have a thing that kind of does that for XFS metadata, and maybe we should just make it do that for file data also.
Yeah, so I believe XFS and ext4 are the two file systems that have a sysfs file system type block device name interface. I don't know that it's fully standard, but it might make sense to make that be sort of a standardized interface for at least some of these tunables. So again, that's probably going to have to be an FS-devel conversation. The other note I'd have is for some of these, the device has fallen off and it's never coming back. Right now, the file system is forced to have to try to intuit that by looking at the error code types. And I've actually wondered for a while now if we would be better off if there was some way that the block device could actually tell the file system the device has gone away and it's not coming back, so that we can actually do something that affects, like, for example, right now, for a long time with TTY devices, when you get a hang up, the file descriptor becomes, has its file ops replaced with one where reads immediately return EOF, and things immediately fail the moment you try to read the TTY. BSD has something equivalent with the revoke system call, where you can basically revoke a file descriptor, and then that file descriptor gets errors the moment you try to read or write the thing. And it seems to me that if we know that the block device is gone, and it would be nice if we got an explicit notification of that fact from the block device layer, we could then immediately invalidate all the file descriptors and clean up a whole lot of stuff, as opposed to having a lot of, oh, write back is failing, and we think the error means that the device is never coming back, and we do, we role play certain correct behaviors. And I wonder if instead of trying to make the file systems guess, we actually give the file systems explicit knowledge where that's available. So that's something I would love to see. That's, again, this is one of those, if we had an LSFMM this year, it's a perfect LSFMM topic because it involves block device interfaces.
I also have a recycled question from, 2014 or so, which is, should block file systems actually register themselves as clients of the block devices they talk to, so that sysfs has a nominal path? You can find something pointing to the file system through the device tree, and most importantly, when you want to freeze or suspend the system, then we can just have the PM code just walk down the device tree and say, hey, file system, freeze. Instead of this goofy thing that XFS does now, where our background threads get randomly shut down with no warning or control by us, which means that sometimes freezes don't succeed because the XFS buffer work queue handler thing gets shut down before the rest of the file system, and so the rest of the file system just stops.
You might not want to actually just freeze the file system, because if the file system has, say, 2 devices and one of them dies and it's mirroring across them, you don't want the file system just freeze, because there's still the other device. So,
well, no, I think you want to notify.
There's an error, do something appropriate.
Yeah, I think you want to notify the file system in the case of a power management event, so the file system can quiesce everything in the right order, right? I think that's sort of the point.
Yeah, I mean, you'd also have to do things like making so that the loop driver, if it's attached to a file system, to a block device or a file on a local file system, can also communicate that particular thing so that all the file systems get frozen in roughly the correct order. And I have no idea what you do for network file systems.
Network file systems get complicated because there may be a cache involved that's on disk.
But yeah, like right now, it's really hard to figure out, given a block device, is there still a file system somewhere attached to it? Because insert system decontainerization hand waving here such that I unmounted the file system, but it's really still secretly mounted somewhere else.
We basically just need a block device tree. A device tree that has the block devices, raw block devices at the bottom, and then goes up through all the RAID devices to the file systems mounted on those, and then loop back mounted on those all the way to the top, and then we can use that to say to prevent loops being made.
I mean, the file system kind of knows that, because if the block device is in use by the file system, we disallow exclusive opens on the block device. It's not really explicit as this file system is using the block device, and we're not exposing that in sysfs or in any of the other trees, right? So we have about half of it done. It's just we haven't done the rest of it.
Yeah, but there's also compounding. So where you're looking at what you think is a block device, it's not a block device, it's actually a bunch of possibly bits of block devices glued together.
Yep.
So part of your file system may disappear, but not all of it.
Right, yeah. But we would register the device mapper, and then device mapper would need to have a way of understanding that, when the underlying block device is about to go away or is about to be frozen, that you notify all of the users. And yes, you have to essentially traverse the tree.
Does that mean everything should be device mapper?
It doesn't need to be device mapper. It needs to be sysfs K objects, right?
Well,
I mean, we have this issue today with like partition tables, right? You can be opening a block device which is, you know, owned a partition on a block device. That's not going through device mapper, and you know, it's the same principle.
Aren't we talking about inside the kernel though? SysFS things don't matter. Because we talk about one kernel thing looking at another kernel thing directly.
That's because it's K objects. It means K objects, following the K object.
Yeah.
Dependency tree, because it's a natural way to just like express the dependency tree of all.
I'm not sure K objects are natural, but
it's the fucking system we've got. So like I think that it's reasonable to go this way. You know, ButterFS links and the devices, because we can have a bunch of devices under a thing, but if you go onto the device, it doesn't know that it's linked to the file system. If we could like close that loop, it would be nice, because then it's a nice, easy way to like describe like the dependency tree.
I mean, K objects are it's the devil we've known for how long?
Yeah, it's what we fucking got, right? Like if it's got problems here, we just attack this problem and, you know, deal with the fallout.
Yeah, because there was that abortive attempt 5 or 6 years ago to actually hook up file system freeze to the suspend and resume code, and that never went anywhere because we tried to do it just by walking the super block list in reverse order, but that obviously doesn't work. Now that you've got me thinking, I started thinking, well, what does happen if you have a file system running on top of device mapper and then you create a loop device and then install that and then use device mapper to install that as the backing for the file system that the device is on?
and you can do that multiple layers, I guess. Have a loop device and a loop device and a loop device.
So yeah, this kind of sounds like expect more horrible FS tests from me in the future.
You need to propagate any errors all the way up through all of them.
Yep.
And it might make sense if the loop device is just a scaffolding element in your block device tree.
Yeah.
In some ways.
Yeah, and the loop device could be a physical volume on an LVM setup, which, yeah, it can get arbitrarily complicated.
Yep. Anyways, so we're pretty close to the top of the hour. So any last thoughts from anybody in the audience?
Actually, I don't know what happens at the top of the hour. Maybe the live stream stops or why not? Could I solicit, Joseph, a question from you about the raw encrypted IO thing? I think you guys dropped the effort to make it generic and decided to go with ButterFS specific API. Do you care to comment about that? Is it interesting for anyone?
I mean, it's interesting if you like have kind of raw, like if you have encrypted data or compressed data. So what Amir is talking about is Omar had an interface to do, it's called RDUF encoded. We're going to use this for ButterFS send, and that we want to be able to, instead of decompressing compressed extents and sending it over the wire and then writing it to disk and recompressing it, we want to send the raw compressed extents out through the send file and then write the raw compressed extent to the disk, so we don't have to do this decompress, recompress step. Omar tried to get it through a generic interface, a pwrite flag that Dave Chinner suggested. A lot of back and forth, and we're going to put it in the ButterFS ioctl. I mean, it's interesting, it's interesting for ButterFS because it saves us time in pushing around send and receive things, which is helpful now with compression, will be helpful later with encryption. We won't have to decrypt and then re-encrypt. We can just push the encrypt bits across. I mean, we're the only ones who do anything like this.
This could actually be interesting for AFS in the future as well, because I mentioned earlier that they're looking at pre-transport compression, and the file server will actually store the blobs you give it compressed. So that might be an option for something AFS could use as well, where the application compresses it and gives it to file system just to transport pre-compressed.
So this is, I think this is more specific in that you do send, which like gives you a like a stream or like a file or whatever, and it says this file extent at here, and it like is the raw compressed stuff, and then on the other side of it, we literally take the raw compressed thing and write it straight to disk instead of like going through.
That's what I'm talking about too. Yes.
So like, but the thing is that ButterFS will decompress it when you read it back. It's not just like it's not like you have user space compressed data. It's like the ButterFS file system compressed it, and then
the scenario I'm talking about, the AFS server will store the compressed blob on disk, and if the next client tries to read it, it says I support compressed transport, it will give, here you are, here's the compressed blob back.
Yeah, so it was the original, well, the original was ioctl, and then Omar switched it to a generic. But then there was a lot of disagreement between Vero and Linus and everybody about whether or not how the interface should look or whether or not it was useful, and said fuck it, back to ButterFS ioctl.
Probably what color it should be. Yeah.
For what it's worth, I wouldn't mind hearing about what's been going on in ButterFS land lately. But I have no idea if they're going to kick us out because it's 11 o'clock now.
Right. I don't know. Let's wait and see. Yeah, I don't know. There's so Omar is working on per subvolume encryption. That's going to tie into FSCrypt, so it'll look a lot like FSCrypt does on ext4. He's making pretty good headway with that. Boris got an FS Verity support, so now we have FS Verity support in ButterFS as of 5.15, I guess. I wasn't paying attention. There's been a lot of work on the zoned support. So we have zoned block device, native zoned block device support. The ZNS stuff has gone up too. So this is like the zoned namespacing thing. So we can differentiate between like the different zones that these like fancy SSDs have. Those patches are pending. The ZNS patches are pending. The zone stuff has been in place for a while. Works pretty well. I say a while, but it's like 2 or 3 releases. I don't know. Fuck, what else? Subpage block support, block size support. Q has been trudging along with that. It's just nothing we ever really cared about, but with ARM stuff, it's a little bit more necessary nowadays. So that work is going in, which will make it easier for us to convert the rest of the buffered stuff to IOMAP. The direct IO IOMAP stuff has gone really well. We love IOMAP. I have a really big format change that I am currently working on. It's what all that bullshit behind me is. Just a bunch of design stuff. I've been working on it for 2 months. Hopefully by the end of the year, I have code. It not fixes, but it changes a lot of the design decisions that we made in ButterFS that kind of cause us problems. It's going to be like it's a relatively big format change, kind of equivalent to like, XFS when they do the V4 to V5 and that sort of thing. We cram a bunch of shit in there. This will make things like relocation faster. It'll make snapshotting faster. It'll make queue groups faster. It takes care of the write amplification in the like silly cases. Generally speaking, write amplification is better on ButterFS in production for us. But there's some corner cases where you can make it look real stupid. So this is kind of to address that. We no longer reference count metadata. We don't, the way cow works, our reference cow stuff works currently is every time you cow a block, you have to push references for all the blocks that you point to. You do this as you walk down the tree. So you can get like 10,000 updates in the worst case for modifying one block. And then on top of that, you have the extent tree, which you have to update. And because the extent tree is reference counted, that like progresses as well. So this format will be one block. Like if the block is shared, there's one update per level as you go down. So worst case is 8 updates, and the extent tree doesn't get touched. The free space tree doesn't get touched. So there's way less amplification. So that's the next big thing. Johannes is working on some substripe stuff. This is going to be kind of the way that we replace the RAID 5, RAID 6 code. Can I talk about Neil Brown's NFSD proposals? I mean, what Neil decides to do is what Neil decides to do. The problem here is that we have subvolumes which have their own inode space. So essentially, what we have is a 128-bit inode number, which is subvolume ID and inode number. There's no way to express this to user space, much less NFS. And so there's a lot of contention there about the right way to solve this. I think Neil's last proposal was to give us a way to just like XOR the subvolume ID onto the inode number so it looks unique across multiple subvolume IDs. I think that's a reasonable path forward. A reasonable short-term path forward. The best way to do it would be to expand and modify interfaces to encapsulate all this information. But yeah, changing big interfaces for POSIX is like not a fun and exciting thing to do. Yeah, I think that's pretty much it. You know, we continue with like the normal file system-y bullshit that everybody does. Like there's a bunch of interesting things. We have nightly, we spend a lot of time with like changing our processes to make it easier for new contributors. Lots of patch review stuff, lots of integration to GitHub to make it easier to track status of patches. I have nightly tests, nightly XFS tests runs, like 10 different configurations, Raspberry Pi, bunch of different stuff. I have nightly performance tests that run against our development branch. So like we've drastically cut down the number of regressions that we introduce. So it's kind of interesting process things there.
Yeah. Yeah, I mean, I guess the nice thing about working for a cloud vendor is that it's made it really easy to run dozens and dozens of FS tests configurations every night.
Well, I've got it's not Facebook, right? I've got a NUC sitting right there on the floor. It's got 5 VMs that run three different FS configuration sets per VM. And then in the other, my closet, I have a Raspberry Pi and some fucking machine that runs performance tests, and that's all my job. So it's nothing complicated. The code is on my GitHub. Like,
yeah, I mean, at some point it might be time to have a FS tests. Let's all share our scripts collaboration session, because you have your stuff, I have mine, Ted has his own stuff, and it's like we're kind of duplicating all of this. Build a bunch of software, lob it at a VM or something, and then slurp up the results into something that looks nice.
Yeah, I used Ted's shit forever. I loved Ted's stuff. The only reason I went this way was because I wanted to have a way to visualize it. I'm tired of like every patch I write, I have to run XFS tests first to get what's failing currently, and then apply my patch, and then see what new is failing. This way I can just look at my fucking website and see, okay, this is what's failing, and I got the same.
Oh yeah,
answer.
Same here. And now I have a bunch of that, and I've turned into some web jockey.
Yeah, oh God, it's terrible, dude. I hate it.
Yeah, so that's one piece that I think it'd be great to see if we could find some way of collaborating on is how do we take the JUnit XML results files that XFS tests can generate and import it into kernel CI, have some sort of analysis tool so we can detect a new regression or detect regression flaky tests, because I'm just eyeballing email reports right now, which is not great. We've got better tools internally at work, but they're all specific for our internal infrastructure, and it'd be great if we had some sort of shared open source dashboard analysis system for doing all of this stuff, whether we leverage kernel CI or we use some sort of other system that, because other people must have done this for JUnit XML, right? So, and Derek, maybe you've figured out some of that already, and I'd love to, steal your scripts if they're available, right?
Yeah, it's a little tricky because while I would love to use GCE XFS tests, I currently don't because I wrote a whole ton of file system testing scripts before that existed. And every year I say, well, if I have free time this year, maybe I'll finally port it to that. And of course, free time doesn't exist anymore.
Yeah, this is the problem that I run into is like, I had some problems parsing the XML format. It just like didn't work sometimes. And like, I need it to be visible to everybody. And I'm not a fucking web programmer, right? Like, I'm not going to sit here and write some like magical web app that I can parse things to and from and whatever. So like my thing literally like just dumps to scrapes the raw like results file from the XFS results directory. You'll see I sent a patch to like make sure the results directories were all separated out. That was why, because now I can just copy it into a GitHub or a Git repository, push it to a server. The server like has a Python script that like parses everything and then spits out a static HTML file, and like problem solved. It's the same for like the performance testing. Performance testing is more complicated. Like it has a SQLite database that it dumps to, and then like there's just a Python script that reads the SQLite database and spits out graphs and shit. And we're done.
So there are Python libraries to parse the XML, and you don't have to use my whole infrastructure. I can hand you pointers to the Python scripts that will parse the XML. That part isn't that hard, or at least that's the part I figured out. The part I haven't figured out is putting it in some sort of MySQL database or SQLite database and the HTML emitting part. And again, it's the same problem as Derek, which is like, if I had the time, I'd be working on it. But usually I can only find the time when I can like, dump the work off on an intern project or something like that. So yeah.
Yeah, like I would love to have a heat map of which tests are actually failing regularly on which configurations so that I can spot new things. Like right now, I kind of just eyeball it because I kind of know that which tests are the ones that don't work on XFS.
Yeah, I mean,
but
like that's what I did with this thing was like, it's got what's failed in the last few weeks, right in the last week, what's given me demessage errors. And a lot of this is like the whole failure thing. There's things that like, if you click on the individual test, like it tells you where it's failing in what thing and what like config it's failing, and then you can go and look and see why it failed. This is where the DM flaky failing to set up thing, like it really shows up. Like I had to disable that because like occasionally DM setup just fails to create the thing and it does it randomly. It's been doing it for years. And then now I have like the data to show that it does it like pretty consistently. Like I get at least 1 or 2 failures in that vein a night. So.
Yeah, I see you've clearly gotten further than I have with your web dashboard.
Yeah, it's just like the Python. There's like this Jinja, I think it's called. It's like a formatting thing, and like you just give it a dict, and then like my dict is really stupid. It's just formatted, but like sorted by dates or whatever, and I just spit it out.
But yeah, but like I didn't even know that much. Like, I assume that there must be some kind of quick and dirty turn a bunch of Python data into fancy-ish HTML, but yeah, I'm already too busy with just keeping XFS working without exploding.
Right. Yeah. This was like purely just, it's when the like testing, like when I'm spending too much time like trying to figure out testing, it's a time to stop and like make it work and then move on, because this has saved me a huge amount of time in the long run. And if we could make it so it's not just, the 3 of us or 4 of us that have our own setups, if we could get some poor intern to like make it work right and put it up on, kernel.org or whatever, then God, that would be awesome. And like, they don't even need the hardware. Just as long as I can run my tests and upload it to somewhere, then perfect.
Yeah, I have kind of thought about code dumping to to the FS tests mailing list of, hey everybody, here's the giant horrifying pile of shell scripts and Python crapola that I use to dashboardify FS tests. But I've kind of wondered if that would really actually be useful, since it would be a giant code dump, and I already get enough crap from people from sending, dozens of patches to the mailing list all at once.
I'm trying to get Konstantin to jump in here. He's not responding right now, but it seems to me that having Konstantin work on some of this would be within his in his wheelhouse. Certainly, if you wanted up on kernel.org, it would seem like he needs to be involved somehow.
Yeah. I mean, the LF does have funding, right? Which is what, it's not Constantine doing all the work himself. He's actually, has hired some consultants to do some of the public inbox stuff. So I suspect if we could figure out some sort of like common set of interfaces that we could then, define in terms of this is what we would actually hand off to Constantine, and that's one of the reasons why I was thinking the JUnit XML, because XFS tests present, has that natively. We have that even if we're not all using it today. Maybe that's something that, if we could have a wish list of, this is what it should do, this is how we feed the information in, and whether it goes through kernel CI or we set up this new system that has the dashboard, I think it'd be really, really useful. Performance is probably going to be a little bit harder because I think the tools are all slightly different. I'm using the Phoronix test suite, which is not great, but I got it working with the minimal amount of effort, which was my criteria. I know other people are doing other things, but maybe XFS test is a good starting point, at least in terms of test failures. Figuring out how we get performance numbers would be great, but maybe that's the second project, maybe.
Yeah, XFS tests we all run, right?
Yeah.
So if we can, and we're flexible, right? So if there's problems with the format, like the people can just fix it, and nobody's going to complain. And then it's just a matter of having something that is relatively easy for me to just maybe drop in a couple extra config options into my local.config, and it automatically just runs its tests and spits out the results to the web server. And then, whatever service they stand up, whatever. And then that way we can have a good, easy way to visualize everything. Performance is always going to be harder.
Yeah. Oh yeah, I did have one other question for you, Joseph. So last week people were chatting in the ButterFS IRC channel about, was it subvolumes and queue groups? And how, I guess journal D has something where it tries to pre-allocate space for log files, and if it thinks that it's starting to run out of space, it will back off on those pre-allocations. But I think it was something like if you have a subvolume for var log and attach it to a queue group, and the queue group is running out of space, but the file system isn't, the statfs results don't reflect the fact that you have X amount of quota and you've used so much of it. So journal D doesn't back off and you just run out of space. And I wondered if that was supposed to be that way, but I also don't really know enough about ButterFS queue groups to know if this is the thing where I mention it and someone says, oh yeah, that's totally broken, we should fix that, or if that's actually just the way it's supposed to be for reasons I don't understand.
Right, we just don't tell you. The queue group stuff is completely separate. So all of the tooling is separate, all of the interfaces are separate. If you want to know you're running out of quota space, you have to ask the queue group. You have to use ButterFS quotas or whatever. There's no way for us to tell. We don't use the standard notification methods, right?
Yeah, because XFS and I think ext4 project quotas do actually do that, where if you set a 100 megabyte quota, then it looks like you have a 100 megabyte file system.
Yeah, that's No, for us, it's just you have to call into the Q group stuff. That's completely separate.
All right. Well, I think I've kind of run out of things.
Well, thanks to everybody. We went 20 minutes over. That's not bad. Oh, Steve's here to yell at me.
Thanks to Amir and all the folks who've been organizing the file system track. I think
Thank
you
you
guys
too.
did a great job.
Yeah, thanks, Amir.
Yeah.
Holy shit.
Thanks,
Yeah, thanks
John
y'all.
and Joseph and Ted. And all the speakers, of course. We have a prominent speaker, Derek.
Yeah, I forgot. Thanks to Rick, Christian, and Willie, and everybody for chiming in and doing stuff. Allison.
I'm just here actually not to yell at you, but also just say we have a Yvette file system talk tomorrow at the Tracing MC that I'm hoping to get file system folks to come and say what we're doing wrong. So come and heckle us tomorrow. I just posted on the link when it is.
Perfect. I'll make sure to be there.
Oh, it's all wrong. And could you please rewrite the memory manager?
Sure, we'll just do it worse than it already is.
Perfect. I got it on my calendar.
Thank you. And also save your notes if you've made notes.
Yeah, I don't think there's anything in the shared notes.
Yeah.
No, John has been keeping notes.
Okay, so I'll be asking all the microconference runners for a write-up of what they've done. So
perfect.
Hope you had good notes.
Hope so too. All right, thanks, Steve.
Right.
Thanks.
Thanks.
All right, thanks everybody. I'll see you all later.
All right.
Bye.
See you at the next whatever conference we end up having.
Yeah.
Bye.
Bye. Oh yeah. So if anybody wants, I could hang out in one of the hack rooms this afternoon. But I should probably go have lunch since it's been like 5.5 hours. All right. Bye, everybody.